Okay, so welcome to class, week 4 of the term. September is almost done, and we are all precariously hanging onto the cliff sides with our fingertips, right? So that's my ridiculous way of just acknowledging. I know things are getting hectic and pretty tough right now. So I just wanted to begin by stating that I know we have an assignment due this week. And then it was been brought to my attention that I have failed to talk about the assignment in class, which is incredibly shitty of me. So I apologize for that. We'll talk about that. I'll extend the deadline by a couple of days, give you a little bit more breathing room. And we'll talk about the date for the second one as well. And we do that. So no worries about that. Okay. So we'll just get that out of the way right away. It's my bad, not yours. And also just a temperature test of all of my classes reveals that we are all okay right now. And so I'm going to try to maintain the general sense of being okay by giving us a little bit of breathing room. And you've all been very kind with me and patient with me this term. Unfortunately, that's one of the side effects of teaching a course I haven't taught before is I can't fall back on some of my normal crutches that allow me to get through my own kind of ebbs and flows of energy throughout the term. So apologize. And I've also started to realize just how much over preparation I'm doing into lectures and stuff. So I've been kind of scaling back on that. So hopefully moving forward, things will come back to you in a more timely manner and or be posted on Blackboard in a more timely manner, and we'll have some more opportunities to do with this. So our goal today is basically twofold. We're going to go over the assignment number 1, and then we're going to get into dating techniques. So we're going to talk about some big picture concepts that we'll revisit next week as well when we do chronometric methods, and then we'll get into relative, and then we'll talk a little bit about this week's readings. One, which is meant to be the Wintle 1996 one, which is meant to be a bridge between this week's topic and next, right? So a really lovely, albeit a couple of year old, 15 years old now, summary of dating techniques. And then we'll talk a little bit about an exercise I thought we could do towards kind of participation or whatnot in this course. So we'll talk about that. Okay, assignment 1, literature review, but this is not your standard literature review. Okay, this isn't the same way you've seen it in other classes. So in this one, I wanted to kind of combine some different ways that archaeologists collect and represent data in terms of using tables with getting you exposed to a wide variety of topics and different kinds of research that people are doing in the archaeological sciences to hopefully help you come up with a topic that you are interested in and pursuing for the subsequent assignments for the rest of the term. Okay, so that's the goal for this first one. So all of my assignments this term will begin with this written overview, just little statements about what the purpose of the assignment is, how the scaffolding is going to work, gives you an idea of what's ahead. As the assignments go on through the term, what you will see is I'll talk about, okay, in your last assignment you did this assignment you're doing this, and this is how it's going to build into the next one. Part of the reason why I do that is so that you're also aware of what you can and cannot be reusing from one assignment to the next, right? So remember that when I talked about the beginning of the term, under a scaffolded structure, the goal is that you're continuously building upon the work you've already completed, right? So the goal is that you're kind of self-plagiarizing in an ethical manner throughout the term, right? That you're constantly building upon it, you're using what you're already worked upon, and that is all contributing towards your final project. Okay, so let's look at this first one. What are we going to do? This is where I get to fight with the computer, which is always fun. Okay. So at some point, by the way, you're going to write a prospectus. After you write the prospectus, you're going to undergo peer review of it. You're going to give peer feedback, so we'll talk about that. And then you'll have your final project. So what is the first assignment here? This so-called literature review. I've been getting lots of questions about it, which is great, and so I'll provide some clarification on that now. So as you can see here, the purpose again is twofold. First, designed to familiarize you with some aspects of the literature. Also, although I realize that this being like a 400 level special topics course, most of you have engaged at least in one manner or another with the library databases, but this is a more formal approach to using the library databases for specific means. Okay, I wanted to introduce you to a wide variety of literature that, again, you don't have to read or engage with in a detailed sort of way, but just kind of get a superficial understanding of what's out there. And again, the goal ultimately of this is to get you thinking about potentially what your final project might be. So there's a couple of parts to this assignment. What's the first part? Is you're going to be reviewing 2 past volumes of the following journal, so of archaeometry and of the Journal of Archaeological Science. So one of the questions I get is, what do you mean by volume? Because some volumes have several issues. Well, if your volume has several issues, actually might as well, oh, yeah, I guess I can do it. I'm having issues signing into McEwen's website for some reason. So let's go to library. And like every good academic, I have the library email address or website location memorized because that's what we do. And so let's start with by finding where our journals are. So we are going to go down through and we're going to go to Browse Journals. And for this one, I'm trying to make it very easy for you. I've picked e-journals that have, or journals that have e-journals, so you don't actually have to go find physical copies of this. At large institutions such as the University of Alberta, which has something like couple dozen libraries across campus in many different places. They have lots of physical copies, but increasingly most collections are now being managed online. So I thought we'd use journals. And so let's start with archaeometry as our first one. Oh, it pops up right away. So we're going to go start. Oh, for some reason, it doesn't let me click on it, but we'll go. No, I don't want to do the whole thing. We just want archaeometry. Okay, and then we're going to search. Boop, boop, boop. There it is. I'm going to pull it up. You can also look for this in the search bar. I like to use it in the actual e-journals because if you don't do it in e-journals, oh, sorry, this is really small. Let me increase the size of it so we can see. Enhance, enhance, there we go. And in this case, we only have one option. So the Wiley, one of the Wiley online libraries, so we'll go there. And what you should see is this. And they will have copies of, or they should, because we have institutional access to all of the, at least going back to, I think, what did it say, 1990 something, 1997, journals in archaeology. So let's go to Browse. And if you go to all issues here, we can now pull it up. And so what I want you to find is a volume. So I'm just going to randomly go back. Oh, it looks like they've actually pushed it back into the 50s. But I want to see something more recently, so I'm going to go in the last decade. And what number do I like? I like numbers with 3 in it, so we're going to go 53. So I'm going to look at volume 53, and I will see that in volume 53, there are 6 issues I need to review. And you're like, oh God, that's so many art issues. But now I need to figure out, well, what am I actually figuring out about these various issues? So how do I fill out this table? So what I would like you to do is document the frequency of basically different kinds of articles or different kinds of reports, right? So notice that don't include letters to the editor, editorials, book reviews, philosophical commentaries in your tally. And I'm going to go through, and so in volume, so I've picked, what volume did I pick? 53? Is that what I picked? Let's go back here. Yeah, in volume 53 across 6 issues. So I'm going to type that in here. So volume 53, what year is this? This is 2011. So I'm going to go back here. So I'm going to type in 2011, or you can keep year there, it doesn't matter. And now what I'm going to do is using the table of contents. So let's start. I like to start in the beginning. I'm not going to go backwards. So I'm going to go to issue 1. And I'm just going to go through the table of contents, and I'm going to see how the journal article content is captured in the table or vice versa. Okay, so what are the things I'm looking for? Well, in the first part of the table, I want to look for the purpose of the study. So recall that we have kind of 5 main questions that we can address in archaeometric research. We can do compositional structural analysis, technological analysis, provenance or sourcing, dating, prospection. In some cases, it might be other, it might be like a multi-component study. And so what I'm going to do is count and see how many articles within each volume, right? So in all of the 5 issues or 6 issues it was, represent one of these purposes, right? And so there's a number of ways you can do this. I don't know what your style is. My style would be, because I'm a big tally and hash mark person, is what I would probably do is as I'm looking at the table of contents, so I'll see the first one here, a study of obsidian source usage in the central Andes of Argentina and Chile. Okay, so sources. So what's another word for sourcing in archaeometry? Let's look. Is that compositional structural analysis? Maybe. Technological analysis? Maybe. Oh, there's a category for provenance and sourcing. So maybe I'll just put in a 1 for now. Okay, there we go. Or maybe I'll just put in like a little tally mark, right? So just 1 for one article. In the article, it also said, oh, obsidian. Okay, so now I have to see if obsidian's in my table. And so I scroll down because you'll see the next part of the table is around the material. So we've addressed what our research question is. Oh, sorry. I hate this computer. The next question is materials analyzed. So is it analyzing with metals and alloys? No, it's obsidian. Obsidian is a lithic or a stone. So I'm going to put my little mark in there. Now I have to see what else I have to fill out. Oh, I'm going to go through. Oh, technique used. Well, there is a ton of techniques on here, right? So it's over 26 because there's more letters. There's 28 techniques here. So I'm going to go back here and figure out which technique is being used. Well, it doesn't say in the title, so I'm just going to take a quick look at the abstract, because again, my goal is not to read all of these articles. I'm just doing a very quick survey, right? So what do I see here? It goes in the abstract. We present the results of XRF analysis. Boom, perfect, exactly what I was looking for. So I'm going to go in, find XRF. Oh, it's A right there, and I'm going to add in my tally. So I'm done for the first article. So I'm going to proceed to do that for every single article in this volume. Okay, so I'm going to go through and do this for the rest of the articles in volume 53. Okay. And so I'll keep going through down. So the next one says, oh, it's characterization study of ceramic tile, so on and so forth. And so once I've gone through and I've done my little tally for each of them, you can either leave it as your little tally. Some people, I was like, yeah, you can calculate the percent. So you could do the total at the bottom if you want. Oh, sorry. Right, so I could add a little row in if I wanted to. So I guess I'm not requiring this. And I could go total. So I could add up the total number of articles across that volume. Right, and then in each of these areas, so let's say that we had, at the end, we had 4 tallies for XRF. Maybe it's a special issue on XRF analysis. And so I could always equals 4, or I could represent it as a percentage. So maybe 25% of the articles. It's up to you, okay? I don't have a specific requirement, but what I want to capture is a pattern of the different types of questions, materials, and methods that researchers are using in one volume of the Journal of Archaeological Science and one of the Journal Archaeometry. Okay? Yes?
And then, like, for every, like, for example, that.
Yeah.
And then, if all of them mention XRF.
Yep.
You would, for example, there's 6 of them.
Yep.
You would put 6 tallies there.
For sure, yeah. So you could do 6 tallies, right? Or maybe you'll just do a count and you'll just update it. It's up to you, whatever makes sense for you. Yeah. Yeah. And you don't even have to report it as, again, a full amount or a number. You could just leave the tallies in here, right? So if I see, or X's, like if you use X's, if I see 6 X's, then I know that means that you saw 6 articles with that. Okay. But this will just give me then as a scan, or give you as a scan, when you look at this table, that you will see or get a feel for the kinds of questions, materials, and methods that people are using. Does that make sense? Yes.
And for the ones that, like, for example, there's no, like, electron microscopy.
Yeah.
You just leave that blank. Right?
Yeah, you would leave it. If it's not there, then you can just check it as an other. And if there's no other category, you can add that. But electron microscopy is here. Oh, you mean if there's no articles that deal with it? Yeah, just leave it blank. Yeah. I mean, if you want, you can fill it in with 0. That makes it really clear, but yeah. Yes. Yeah, whatever volume you want. Yeah. Yeah. I don't care which one you look at. It really doesn't matter to me. Yeah, everyone, I think that's what I'm getting based on the emails is every single person is way overthinking this. Like, oh, well, I need to source it. And I'm like, no, you're not. No, this is not a bibliography. You're not telling me the names of the authors. You're just literally tracking questions, materials, and methods. We're just getting a feel for what's going on in the discipline. Because what I'm hoping is going to happen is when you're scanning through one of the issues or through your volume, you're going to see something like this. Oh, manganese studying of archaeological glass. Oh, I don't know much about archaeological glass. That sounds pretty cool. Maybe that would be a good research topic. Okay, so that leads into the next part of the assignment. So are there any questions about this table? Yes. Yeah, yeah, then you'll have more tallies. Yeah, yeah, so if they're like, yeah, chemical analysis of obsidian and chert and granite and 5 other lithic types and maybe some pottery, then you're going to check off lithics and pottery and then every single method that they used. Yeah. So again, this is just simply a quick count of these are the kind of, again, methods, materials, and questions people are asking. You'll notice the questions very broadly. Is it characterization? Is it provenance? Is it dating? What is it? Yes.
So for example, if articles with books or for example,
Yep, exactly. Yeah. So I'm just trying to capture mentions and really focus on just the titles and the abstracts, right? I don't want you reading full articles at this point. Okay? No problem. Any other questions about this assignment? Or at least this first part, part 1? No? And so you'll see that's why I uploaded this as a PDF, or sorry, as a Word document, so you can download it. You can just copy right into here. Again, as long as it's clear and neat and organized, I don't care exactly how you're doing your tallying process. So again, if you want to use lines or dashes or X's, whatever makes sense, right? I promise you I'm smart enough I can figure it out. Yes. Yes. Yeah. If you can answer, if you can get enough of this to capture it, perfect. And if they use other methods in the article, fine. That's fine. I'm not reading all of the journals that you've read. I'm not going through and making sure that your tally is correct necessarily, okay? I'll take a quick peek just to make sure it looks like it makes sense and that you've captured most of it, but this is not meant to be, this is not a busy make work project for you, for me, or for me for marking either, right? This is getting you thinking about the kinds of research people are doing, because chances are up until this point, you have not engaged with any of this literature, right? The likelihood of you actually using like the Journal of Archaeometry itself, very unlikely. Maybe the Journal of Archaeological Sciences, you might have come across in other classes. I know I sometimes assign stuff from there, but these technical papers, very likely not. Okay. Any other questions? You're like, I'm just going to fudge all my marks. I'm just going to randomly put in a whole bunch of tally marks. Don't do that because I'll figure that out too. Remember, you still have to report to me what volume and what year number. Okay. And you'll see, this is 6 marks total. So this should not be hours and hours and hours of label or of work, of labor, right? This is just a really quick and dirty assessment, because what's really critical in this assignment is that I then want you to scan through 6 past volumes of these other journals, okay? And in this case, yeah, it's still 1 volume per journal, not 5 volumes for each journal. And for this one, I want you to determine what percentages of the articles in each volume could be categorized as archaeometric investigations. So you're simply going to report the volume here, the year, and yes, you can use the same one, or actually, sorry, I picked different journals, so you can't. You're going to give the total number of articles that you think reflect archaeometric research. So let's say in the Advances in Archaeological Practice, and this one actually doesn't have tons of articles in it. I think most of the volumes only have 4 or 5 articles. And so maybe only one of them has it, okay? 1 out of 5. So you're going to calculate the frequency of that is 20%. Because the frequency tells us something different, right, in terms of kind of proportions than just the count does. Because 1 out of 5 doesn't seem like a lot, but 20% of articles is actually pretty significant, right? If it's 0, that's okay. If there's no articles that seem to meet our standards of being about, again, sourcing, dating, characterization, technology, or whatever, then it's just a 0. And that could very well be the case. Okay. This part of the exercise is to show you that even though a journal doesn't have archaeological sciences or archaeometry in the title, it actually might still be useful for resource materials for you. That archaeometry is still being published in archaeometric techniques in other journal forms. Okay, so you'll see this one is a little bit more 12 marks because I'm asking you to look at a little bit more stuff and you have to do some math. Okay, any questions about part 2? Yes.
So are we doing all the
Yes. Yeah. Yeah. And don't worry, some of them don't have lots of issues, some of them do. And I'll give you a little bit of a tip. The further back in time you go, the less issues are going to be associated with the volume. So last few years, for some reason, journals have been exploding just because there's so many of us publishing, right? There's just so much research being done, so many articles getting out there. But if you go back further in time, you'll find there's less articles than not. But if you're interested in studying a more contemporary method, looking at more recent journals is much more important, right, than looking at the older ones. Okay. Any other questions about that? Clear as dirt? Okay. The last part, which hopefully you're not stressing about too much, is that hopefully at some point, while you're looking through these various journals, while you're scanning through titles and abstracts and getting a feel for what's going on in the world today, and it has gone on historically in terms of archaeological sciences, something will capture your attention. Okay. And again, I don't care what it is that ultimately captures your attention, but what I want you to do is describe to me in a paragraph, about 250 words, 3 to 5 sentences, because if I don't put in word count and stuff, I'll get 50 emails, or not 50, I'll get 17 emails from every student in the class asking me what. I won't count your words, but I also don't want this to be a 5-page essay. This isn't. This is your initial description to me of what you're thinking maybe you want to do for your final project. Part of this is so that I can also help you with refining your topic, either in terms of expanding it, in reducing it, so it's something that you can actually do over the course of the next few months, right? This is not a master's thesis or a PhD dissertation, right? This is a final project for a 400 level undergraduate course, right? But I can provide then suggestions, tips, and resources to help you refine it and give you some food for thought in terms of what you might want to do moving forward in subsequent assignments, okay? So you're going to describe it. You're going to state what material and or method caught your attention and is potentially of interest for you. I want you to focus on either a material or a method, because as I state here, your final project will look at the specific application of an archaeometric method for addressing a specific research question. Okay. What that research question is, what method you select is up to you. Again, you don't need to get approval for this in advance. I also get this all the time. I don't know. I'm like, no, the whole point of this assignment is that what you would send to me in an email, be like, Dr. Biittner, I'm thinking of doing this for my final project. Does this sound okay? That's literally what you're typing here. Just leave out the Dear Dr. Biittner and then, like the little preamble. Just start right into the, I am interested in doing a paper on this. And then I'll go like, awesome. Or great, but, or have you considered this? Or, wow, I have lots of resources on this because you actually fell right into an area where I know a lot of information. So here are 50 articles about this. Okay. So again, anything. So I give an example. For example, you might want to make an argument about the use of using ESR dating of a particular site to address issues with establishing chronology. So maybe you came across an article that talks about the use of radiocarbon dating at a site. And you're like, oh, okay, well, they've already done radiocarbon dating. I wonder if they've tried other methods because of whatever reason. And so that could be what you're looking at, would be the specific application of a particular dating technique to a site where it has not yet been done. And so your final paper would be more of a research paper where you would give some background about ESR dating, why it's appropriate for use on that site, how you would go about using it, and other sites where ESR dating has been successfully applied. Okay, so that's what we're leading up into. Now note, because this is a Biittner class, you don't have to do a research paper per se. but at least this will give you some groundwork, because if I see opportunity for you to do something like an essay, I will also indicate that as well and say, hey, this would be really cool. Do you know it'd be really cool to do with this? Have you thought about like building a website about this, or doing something else? Maybe making a graphic novel that explains how this dating technique was used at a site and it resolved this huge question that people had. We're going to see that in our assigned reading next week on the Shroud of Turin, where radiocarbon dating was used to definitively establish that the so-called Shroud of Turin does not date to the period when Christ was alive, right? And therefore it is not an authentic artifact for that particular time period. Note that the article does not dispute whether Christ was an actual human being who lived or any of that, but this simply states that no, it does not date to the time period in which this historical figure was reported to have lived. Okay, so we're going to look at that. So that's a good example where maybe you're like, oh, more people should know about this because people still talk about this as an important artifact because of this. However, what our research has shown us is that this is not the case. And then you could discuss the strengths and limitations of the method was used. Maybe propose another dating technique that can be used to verify the radiocarbon dates, et cetera, right? So again, this is just to get you started thinking about and communicating with me about what you're thinking about doing for a topic of interest. And you'll note that I don't care what your final form is for your final project, right? If you're already thinking like, yeah, I want to do a research paper, then throw that in there, because then my response will be accordingly. And if you're like, hey, I'd be interested in hearing some options of how I might be able to spin this into an essay, you can also write that too. This doesn't have to be super formal at this stage. You're going to have a formal proposal later on in subsequent assignments, okay? So is this part clear? The hardest part is honestly coming up with a topic, right? I get that. And I thought about just giving you a set of topics to choose from, but that's no fun. And you're all also senior undergraduate students now. Coming up with a topic should be something you're capable of doing at this point. Ultimately, though, of course, at the end of the day, if you're struggling, you can't decide on anything, come see me and I'll just make up something for you. And then you can just crank it out and just get it done, right? Or we can talk about it. Again, you might come to it because maybe there's a particular site you're very passionate about and you just want to learn more about, and that's going to be your starting point. Cool. That's okay too. Okay, give me what you got. Tell me where you're starting. The tricky part then is the last part here. And you'll notice it's only worth 3 marks, is that I would like you to list 3 articles that caught your attention or that might be of use for your final project. So at this point, I'm not asking you to justify or explain how these 3 articles relate to your final project or your topic or why they caught your attention. I just want you to practice citation of a full article. I would actively encourage you, however, to again, think about ones that you will be able to use with the understanding that you'd like to be able to build upon this work, right? So you already have a little bit of language written about your topic. You'll have a couple of sources you can use for your paper. And again, I will be providing feedback along those lines, not so much grades. You can see marks aren't that important to me in this one, right? Because it's only 3 marks. You get 1 mark per reference, right? But it's an opportunity for me to say like, wow, that sounds like a cool article. I can see why you're excited about it, right? Yes, run with this. Or I don't know what this relates to, but if you're interested in this, that's interesting too, because these are some other things you might want to consider, right? This is my opportunity to give you lots of formative feedback. Okay, 4 parts. Any questions? Oh, yes.
Do you care about what citation style you use?
No, I don't care. As long as it is a correct citation style that has all the key components, then you'll get a full mark for it. I thought about being like making you do APA, but honestly, folks, I'm not going to lie with you. I had an article that I co-wrote with one of our students, actually, one of our formal students. We've been sending it out to try to get it published. We're having some issues finding a good scope, a good journal for the scope of it. But the worst part is every single journal we've submitted it to, so we've submitted it to 3 journals, they've all required different citation methods. They're all anthropology journals. They're all biological anthropology journals too. So they're not even like, we're trying to go from archaeology to bioanths to linguistics, right? Where you might expect a little, no. They're all bioanth journals. They all have different citation methods. So every time they come back and they're like, no, this article is out of scope for our journal, we then have to go and redo all of the citations. So I've just decided I don't care. Okay. Make sure it has the key information. Authors' names, right? The year it was published, what journal it's from, the issue, page numbers, title, right? The core components. How they're in order, that I don't care. Okay. I'm done caring about that stuff. What I do care is you're citing and you're trying to do it in a way that's coherent, logic, and consistent. So if you want to use MLA, APA, whatever format, as long as it's one of the recognizable ones, I will recognize it too. At this point, I feel like I've seen it all. The best is when you get journals who just decide they're just going to do whatever the fuck they want. And they're just like, let's just do this random format that no one else uses. And you're like, great, thanks. One of the articles I published in, we have to provide the full names, not just like initials. So we had to go back through and search all these authors to try to find their first names. Like, who cares? Right? This doesn't matter. Like, what? Talk about tedious work, right? Like, I'm just done with this stuff. Can you tell I'm mad? I wasted so much time this summer redoing references for this damn article. Anyways, yes.
For the full references articles, do they have to be articles that were within this co-op?
Great question. No, they don't have to be within this. You can go off and explore. If you keep it to the article, the journals I've listed here, then you're saving yourself a little bit of extra work. And these are the big ones, right? I tried to pick really big ones in Anth. So of course, the ones in the first table are the two big archaeological science journals, right? Archaeometry and the Journal of Archaeological Science. These other ones are also ones where we have this as well in it, right? So Advances in Archaeological Practice is a more recent journal. It's only a couple of years old. So it doesn't have kind of the same depth some of the other ones have, but it has a lot of contemporary ones. And also what's neat about them is they're written to be accessible to a general audience as well. So one of their mandates is that they're supposed to be explaining archaeological methods or archaeological practices in kind of a very accessible, kind of like explain like I'm five sort of format. Okay, maybe not quite that simplified, but they're supposed to be very short, condensed ones. American Antiquity, one of the flagship journals of the Society for American Archaeology, they publish on everything and anything. Same with Antiquity. Journal of Archaeological Method and Theory is another one where you'll see a bit more content in terms of archaeometry, but it depends on each issue and volume. Same with Journal of Field Archaeology, and then World Prehistory is just a good one for getting kind of a global perspective. And World Prehistory doesn't have tons of articles each issue. Most of their issues are special issues, so they'll all be about a particular time period or a particular part of the world or something like that. So, but yeah, if you want to find something from somewhere else, go ahead. Journal of Anthropological Archaeology, knock yourself out. Try to keep them within archaeology journals. It'll just make your life easier. Yeah. Might get a bit wonky for those of you who want to do work on sites in the classical world, because then you might start to end up in other journals and things start to get a little bit wobbly there, but that's okay as well. We can figure it out. But the big thing I'll probably respond is if you go outside of these journals is, if I don't recognize them, is are these anthropology journals, are these archaeological journals? And if not, keep in mind that for your final assignment, you will need some that are derived directly from archaeology. Yeah. Okay. Does that make it clear? Does that feel a bit better? Okay, and again, I'll post a bit of an extension so you can have a little bit more breathing room around this, okay? So because this is the first assignment, because we're starting things off, I want to make sure that you feel prepared going into the next assignments, okay? And I'll get, I think assignment 2, have I posted that one for you yet? No? Yes, yes? I'm seeing mixed. Yes, no? Okay, good. I was like, I thought I posted it. And then I'll post the third one as well right away here. I've just been tweaking it, so I'll make sure that those are there so we can look at those, and we'll look at those next week. Okay, any other questions about this assignment? Speak now or send me an email later. I was going to say forever hold your peace, but that's just a lie. Like, yeah. Do I have? Personally, no, our library does. Not the 2? Oh, sorry, I should have checked for that. Send me a message and we can come up with a solution for that. If accessing and reading journals online is a problem, we can figure something out. That's not a problem. Yeah. Yeah, and the reality is just that sadly, is increasingly institutions aren't keeping these anymore because it's just the amount of sheer volume of these paper copies of these journals is just huge. I used to get a few, but I don't get any of them anymore. I just have digital subscriptions now for the few the library doesn't provide, because it's just the amount of space. I had boxes and boxes full of American antiquity. And I was like, what am I going to do with these? Like, just randomly sit on them? So, yeah. Okay. Seeing no further questions, let's close this part down. I'm not going to save that. We can close this part down. And before we go here, I thought we could just look briefly at this, because this will help for subsequent readings from this point on. And we'll actually apply some of this for one of the readings today, not the winter one, which we'll talk about momentarily, but the other one. So I prepared this for some of my other classes, my 300 level classes, where I have students read quite a bit of stuff. And it's because one of the things that we're really good at doing in academia is asking our students to do critical reviews of pieces of work, and then we don't actually explain what we mean by that. So I thought I'd outline a little bit more about what I mean when I talk about doing critical analyses of things that have been assigned to me or things I need to read because of what I'm working on. So let's look at some of these things. Oops, sorry, I'll just use this. Okay, so again, this is part of that first exercise, is you're going to be reading like titles, maybe the abstract, and go, okay, what is the purpose of this, right? This is simply the first thing we have to do is go, what kind of article is this type? Sometimes it's explicitly written on the article itself, right? Other times it's not. I'm just trying to see if anyone's had this class where it's talked about it yet. But what, sorry? No, like what kind of journal it is. So sometimes you'll see, like this one doesn't have it, but sometimes you'll see like where it has article info. Sometimes it might say like research report, or it might say like a book review or something like that. So it's just important to pay attention to how the article itself is described. Sometimes you'll see there'll be like letter to that or comment on, or so there's usually some sort of contextual information. So that's one of the first things you want to figure out is, what am I looking at? The majority of what I'm assigning to will be research reports, right? So original research articles where someone is presenting new research about either a new research question they've asked, a new method they've employed, potentially a new material in archaeology as well. Question of who it's written for is always important to ask. Know your audience, right? Things coming in academic journals, their primary audience is going to be fellow academics, right? Other researchers, particularly those who are experts or specialists as well within that same realm, right? So an article that even I would write for archaeometry would be very different from the article I would write for current anthropology, right? I would be anticipating there would be different audiences, there'd be different kind of approaches to materials. When I read something in a journal of archaeological science or in archaeometry, I expect it to have a different level of kind of technical knowledge, right, than I might see in something that was written for National Geographic, right? Because National Geographic will spend, because it's a public facing, it's assuming that people who are reading it are just engaging with information about the past, about research or present, right? They might be learning a little bit, but they're not expecting kind of a nuanced, detailed, educated audience who is going to be aware of the ins and outs of the methodology that is outlined in there. And they often have those little pop-up boxes, right, that explain methods and concepts and whatnot. What is the main argument? This is a question that sometimes students struggle with, and I think in archaeometry, it is the most important thing that we identify, right? What are they doing in this article, right? So this is, again, why we have that table exercise, right? What is the method they're using? What is the materials they're studying? And what is the question they're asking, right? And when we read stuff in class in preparation for discussion, more specific is better, right? So for the assignment, we're going very broad. Is it about dating? Is it about sourcing? Is it about characterization? When we're talking about in class, let's get into some of the nitty-gritty details. Let's see if we understand what is being presented to us in the article that's here, okay? For this, the abstract should clearly state this. If it's not in the abstract, then check the conclusion. If it's not in the conclusion, then this is not a very well-written paper, Sometimes we can't find it and it's not your fault. Sometimes it's because the authors didn't do the best job of being articulate or clear about that. And especially for this class, if you can't figure this out, come to class with that question. Be like, I know I read this, but I still don't know what the point was. That's what we're here to discuss, right? Is to get into it and go, okay, what can we figure out from this article? Because some of the articles I've assigned are very technical and have a lot of data, have a lot of information, right? But our goal is to get comfortable so that when we see this and encounter this, that we don't just immediately have the response of, I can't understand this because it's too technical, it's too complex. So we're going to talk about how we can approach these things and how we can sometimes get at this, even if we don't understand the minuscule details that are throughout. As long as we can get at the major themes, that should be sufficient. What is the most important information presented, right? So what is the evidence they're using? So in archaeometry, we're going to be focusing on that, right? What are the methods they're using? What materials are they studying? And we're going to be assessing things like, and being critical around whether or not they're using appropriate methodologies and techniques for the questions they're asking, or if there's better ways to do what they wanted to accomplish. What are the key concepts that they're presenting? What are the ones that we need to understand to follow their line of reasoning? And this is where looking at key terms and having your course glossary that you can engage with can be really critical, right? Is they can't keep mentioning this thing called chert, and I don't know what chert is. Well, if you don't know what chert is, it can be really hard to understand an article on the characterization of chert, right? So you're like, I know they're describing this material, but I don't know what this material is. Chert is a particular lithic raw material type, particular type of stone. And it's a term we use a lot in archaeology, and we're terrible at defining what we mean when we call something a chert. Because from a geological perspective, a lot of what archaeologists call chert, by the way, isn't actually chert, but that's a whole other issue that we have to contend with. We'll talk about that a little bit later on in the class, okay? So highlight, make notes of the terms you have, use them, put them in the course glossary, bring them to class, we'll talk about them, okay? Sometimes even like, and again, I don't want to say it's like, even I have to look stuff up because I don't know everything anyways, right? I do, I have to look up stuff sometimes. I've read articles where I'm like, I have no idea what they're talking about. I don't know what this is. And then I'll read it, I'm like, oh, okay, now I get what they're using. They're using a regional term for this particular raw material. I didn't realize that that's what this is, but what they're referring to is what I know as this, right? So this happens. Or sometimes it's outside of my expertise. A lot of the terminology around pottery, I always have to look up the difference between like a glaze is and all that stuff, right? Because I can't remember it. So it's okay. So we're going to do that. What assumptions are made? This is really critical, right? So if they are applying a method, there's usually going to be some sort of explanation around the assumptions they made around its appropriateness. If they're not talking about that, that's something to be critical about, right? Oh, they just applied this method and they present these results, but they don't actually talk about some of the limitations of that methodology, right? What assumptions are they taking? Action, what action is suggested? This can help inspire you in terms of research projects, because often we'll see this again in the conclusion where let's say further research on X is required if we really want to have a good understanding of this, right? So implications. Why does this matter? Why is this valuable? Who cares about glass in the Mediterranean? Who cares about chert? Who cares about these things, right? Thinking about it. What is the point of this argument? Especially for archaeometry, because one of my major critiques is sometimes they're so focused on sharing their data and talking about their results, they forget to link it back to people and behavior. And it just becomes a technical report where they're like, oh, we did this neat method, we used these neat tools, we got this data, cool, huh? And you're like, yeah, but isn't this about archaeology? Why is this important? Why is this valuable? So what? Why should I care? Sometimes it is simply like, cool, no one has ever been able to date this material using this methodology before, but it looks like this was successful. That's the so what. Oh, no one's described this raw material type or this manufacturing technique before. Cool, neat. Now this new piece of information is now present for us to use. Okay, so what? It doesn't have to be a big so what, but always ask that. So again, does this then contribute to new things? And at this stage, you may not be able to assess this, and that's okay, right? The goal here is not that I'm asking you to answer all these questions for every article, but have these thinking about it as you're engaging with the readings in this course, especially now that we're transitioning into reading articles that relate to specific applications of archaeometric techniques to archaeological questions, right? Do I get the so what, right? Do I understand the assumptions? Do I get the validity of their argument, or the validity of their argument that, hey, this is really important, right? This is what I want to talk about. Did this article excite you? Was it interesting? Was it engaging? Were you convinced? Or did you just get so bogged down in the technical language that you weren't able to see what the point or purpose of this article was? That's valid critique, right? Not having sufficient background is different from this is so poorly written because they use so much terminology. They never clarified what they meant by this. They just presented the tables were just thrown in there. They're not contextualized, right? Or there's this figure, but I don't even know what's going on here because they just say see figure A, but they don't say what I'm supposed to see in figure A. I hate that. That drives me crazy, right? So pay attention to this stuff, right? And then what questions do you have? Bring these to class. We can talk about them. I may not have the answer. I may be like, I don't know, because they didn't talk about this in the article. You're absolutely right. Did they answer their research question? This is something that's really interesting. I've been peer reviewing now articles for journals. So I'm seeing draft manuscripts that have been submitted for publication, and now I'm starting to be asked to do this. And I've been doing this. And I read this one recently where I had to send it back and actually suggest that it not be published. And I hated to be that person because I was like, I'm not always going to say all research is valid, all should be published. But their title suggested that it was about one topic. I was like, wow, this topic sounds exciting. Can't wait to read this article. And then I read the abstract and I went, okay, I think I see how that relates to the title they gave me. And then I read their article and I was like, wait a second. I thought this was supposed to be about subject X, but really they've constructed a really interesting argument about subject Y. So my response was, this is a really neat article. There's really valuable data. This is a new methodology. It's a new piece of information. It's within archaeogaming research. And so I can't give you any more specifics because it would actually, once it comes out, because I do believe it will get published eventually. Once it comes out, you'll know what article I'm talking about if I reveal, because it's just such a limited literature right now on this. But anyways, so I said, I can't recommend it for it to be published as is, but I think if the author revises the abstract and the conclusion in particular to meet what they actually talk about in the paper, this will be great for publication. What I decided to do is, because I was giving kind of a negative critique, even though I had a lot of good things to say, is I waived my right to be anonymous as a reviewer. And I said, yes, please share my information with the author. And if the author wants to engage with me so I can clarify some of the critiques I had and some of the icky points that I was kind of unclear about, please give my information. And sure enough, the author contacted me about a week later. And it turned out I knew the author. So it was someone who I know and was like, hey, Katie, thanks for your really kind review. Yeah, I know I need to work on this a little bit more. I'm thinking of switching it this way. This is the title I'm thinking. I was like, yes, that title actually captures what you actually wrote about, right? So sometimes these papers make it through publication and you read the title and you're like, oh, and you might have encountered this doing research papers already. You read the title and the abstract, you're like, this would be perfect for my term paper. And then you read the actual article and you're like, fuck my life, this article has nothing to do with it. The number of times I got burned as an undergrad doing that, right? Because I'm like, oh yeah, I have tons of references. I have 5 references. This is going to be easy, right? And then you actually read them and you're like, oh wow, I'm in trouble. None of these are relevant, right? That happens sometimes. So that's the kind of things to be critical about, right? They didn't answer the research question, or they answered this other question, or wow, this is actually just overall garbage, and that's okay too. You wouldn't believe some of the stuff that gets published. That shouldn't. It happens, right? Okay. And then I gave you this. Again, this is specifically what we're going to be addressing. And so I'm going to pop up this slide because I was thinking about this. I was stressing this weekend and overthinking, as one does, or as I do, at least. I shouldn't assume all of you do this, but I definitely do this. as I was stressing over over discussion questions for Grund et al. Right? And I was like, oh, okay, what would be a good question to ask about this article? And then, I decided, I was like, no, wait, I already have good discussion questions for this article. Because at this stage in the course, these are the discussion questions I have for this article. This is what I want to talk about. I was like, let's keep this simple. Let's start with our very first article term, and we'll talk about what's analyzed, or like, I should say really first article that's not just a historical perspective like Wintle, but actually gets into application. Let's talk about this. So what's being analyzed? What's the material culture type? What's another word we can use for that? What are they sampling, right? So we'll talk about what's sampled, what techniques are being used, what is the level of analysis. So we're calling back to that topic, looking at that, and then what questions are being asked. And sometimes you might only get a broad feel that, oh, in this one, they're talking about dating, but this one's more than just dating, right? They're actually asking a couple of questions and packaging it, and that's what I love about this article. That's why I selected it, because it's not just a super straightforward, this is a method or a new method potentially for dating sites. What this says is, oh, hey, we have already this data that we use for answering these kinds of questions. We think we can use it to answer these other kinds of questions as well. And I love that kind of science. To me, that's juicy science, right? Ooh. I love it when people are like, hey, archaeological records a finite resource. What if we maximize? Because to me, this isn't overanalyzing, is it? No, they're maximizing the data that they do have and the samples that they do have that they're already processing and already using to answer questions to go, hey, maybe we can use this to answer other questions as well. So thought it'd be useful to go over those questions. Okay, let's take a break. It's 3 o'clock. Come back in 10 minutes. Yes? And then we'll get into dating techniques. So I'll do a brief introductory summary. A lot of this should hopefully be reviewed from a 206 course. And then we can get into talking about our articles for this week. So as I mentioned, we'll begin with a brief review of some basic concepts in terms of dating techniques, including some of the issues we face, and we can revisit these again next topic, so I won't spend too much time on them after we talked about chronometric or absolute dating methods. There's definitely far more issues in some regards with those methodologies than there are with the relative methods. And I have to add that I always love it when I get to talk about dating in my classes, because I'll like mention it to my partner. I'll be like, yeah, one of my partners will be like, yeah, I'm talking about dating techniques in class this week. And they're like, oh yeah, so what are like dating techniques look like in archaeology? And I'll be like, well, we have like relative methods. And they're like, wait, you teach relative dating? And I'm like, well, yeah, because that's where a lot of it begins, with like the stratigraphic profile. And they're like, oh, okay, so like obtaining dates on stuff. I was like, oh yeah, not on actually like romantic or non-romantic or just dating. This is, yeah, no, I'm not. Yeah. It also explained why they were really confused when I was talking about some of the subjects we were talking about in other classes, and they were trying to reconcile while I was talking about some things. And anyway, so when I talk about dating techniques, no, I'm not going to help you find a date, but I may help you someday potentially date your archaeological site. And by a date, I mean obtain a date for your archaeological site so you can assign a calendrical year to it, potentially. Okay. I also love this comic. If you haven't encountered it, it's called Piled Higher and Deeper, or PhD Comics. George Chan used to write it quite a bit. I don't know if he's as active as much with it anymore, but it has some really adorable ones. And this is one of my favorite ones, is that when we think about relative aging too, we think about how we do relative dating all of the time, and we don't even really think about it, but we do assign relative values of ages to a lot of things around us, right? We can look at technologies and be like, wow, that's an old computer, right? Or that's an old car, or that looks like a brand new car, or that person's younger than me, that person's older than me, right? So that's what we're going to be talking about today, are the methods we can use to assign and assess these relative values. And I love this one from graduate work that looks at, like how the time you spent putting in the lab or the time you spent in academia as a graduate student kind of ages you differently. And, I remember first day of my PhD, you feel like you're so sophisticated because you're a PhD student, right? You finally made it and you're all like mature and stuff. And then you encounter with like the senior PhD students who eventually I would become, who are like, 5 years into their PhD, and you're like, wow, I'm so old, I'm ancient, right? Like I might as well be 100 years old. I've been here forever. I've seen things, children that you have never seen before. And then I always laugh because as a professor, it gets even worse because it's like Dazed and Confused where my students stay the same age, but I keep getting older. And you folks just keep coming in all young, filled with vitality. And it's just, I'm like an energy vampire. I just suck it all from you. And that's what keeps me young and alive is your youth. So thank you for that. Okay, let's get back to relative dating. So no, I'm not going to teach you how to date your relatives. What I am going to give you are some methods we can use to obtain dates from archaeological sites. So remember that when we're dealing with archaeology, again, I'm going to go through this quick as a bit of a review, that we very coarsely and roughly date our methodologies, our techniques into these two categories, right? Relative methods, which will indicate simply to us if something is younger or older to a point of reference, maybe a material culture, maybe a particular archaeological site, maybe to a period of time. Whereas with absolute or chronometric methods, which we're going to look at next week, will give us with actual ages, actual dates that we can convert and understand using a calendar. There are many, 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 many dating techniques. And a lot of this has to do with the history of archaeology as a discipline, right? That after the kind of antiquarian phase, as we have a shift in research questions, one of the major shifts in archaeology as it was emerging as a discipline was how to come up with the ages of the sites and the materials we are working on, right? And early in the history, most of our methods were relative. With the advent of radiocarbon dating, that's when everything started to change, and then we see a veritable explosion in the numbers of techniques that we can use to obtain these absolute dates. And so we'll look at some of these today in terms of the relative methods. We'll look at some of the absolutes next week. And note, when we go over the absolutes, I'm going to spend a lot more time talking about not the specific different methods, but rather the broad categories they represent, because many of them we can lump based on the principles of how they operate, right? What is it they're measuring to capture time? So that's the emphasis on absolute techniques. Whereas with relative techniques, what we're looking at is almost kind of quick and dirty measures where we can establish the approximate, again, younger, older age of the site or the materials that are found there. So when we start to think about the sheer number of methods that are out there and what is applicable and relevant to this course is that we have to remember that all of these methods have limitations, right? They have strengths and they have limitations, right? And also what I want to emphasize is that when we talk about techniques as being a relative technique or a chronometric technique, I don't want you to fall into the kind of pseudoscientific trap of assuming that chronometric is inherently better, that somehow obtaining a date that can be converted into calendrical year is somehow more valuable or more important or more useful to answering our archaeological questions than relative methods are. Because the argument I want to make today is that we must begin all of our dating, we must always begin with description and context, is that all dating has its foundation in the most important relative dating method, which is stratigraphy, right? So don't fall into the trap of assuming, oh, they applied a chronometric method, they got these dates, that those dates are inherently better than dates that have been established or obtained through relative methods. Okay, that's not the case, right? They're all subject to the same, or not the same, but similar limitations, similar strengths and advantages. We need to be critical regardless of the methodology being used. Two ways and two kind of constraints that these methods or our application of these methods are shaped or vary is based on, first and foremost, the material that we can use to date, right? So not all of these methods are created equally. They require different samples, right, in order to produce dates. And this is really important because sometimes people, I find not so much archaeology students, because you usually have this hammered into you, but members of the public, is that all methods are associated with some sort of time range, right? But there's a limitation on the application of these methods, right? So it's either going to be limited on the basis of material or in terms of the time frame. And absolute methods are much more impacted by this. Most of our relative methods, because we're simply saying it's older or younger than, it's not an issue, right? But that's not always true. So you'll see here in no limit. And so one of the things I'd like us to do, and we'll do this as an in-class exercise next week, so I'm giving you a heads up for that, is I have over the years been working on a table that I use in my courses of dating techniques. And it needs to be updated. So all y'all are going to help me with that next week. So we're going to pull up that table and we're going to do some crowdsourcing, and we're going to make sure that the table that I have that I use for teaching has been updated with the latest information regarding what materials it can be used for and what is the effective time range for that technique. Okay. Next week, we'll talk about how that effective time range is determined and established. But for this week, we don't have to worry about that. That most of our relative methods, as you can see here, have no limit. Basically, the limitation is based on what is present in the archaeological record, not inherently linked with a particular period of time. Right? Classic example of a dating technique that has very strict limitations on its applicable time range is radiocarbon dating. And we'll talk about that more next week. Okay? So heads up, that's our activity that's coming up. So there are other issues, though. I like to start this. Again, I show this in my other courses, especially when I teach world prehistory, is that before we even get to talking about dates and how we obtain them, is that one of the issues we face is that there's not always the best consistency in terms of how we report dates, right? And again, this reflects some of the history of our discipline, that in recent years, we've seen a shift away from reporting dates using the AD-BC system, which is very much a culturally specific system, to reporting dates using BP or before present, or BCE, before Common Era, CE, Common Era, right? And we'll talk a little bit more about BP and how it was established when we talk about the history of radiocarbon dating next week, okay? And then, again, to kind of allude to this, that one of the reasons why we should be cognizant of this, and this is the very kind of anthropological, archaeological approach, is that the calendar that we use is not the calendar that everyone uses, right? While that we might think of it as a standard measurement of the passage of time, there is some cultural variation. So this is some of the examples I like to provide, right? That this year, using the Gregorian solar-based system, this is 2021 CE, but in the Islamic calendar, this is 1443 Al-Hijra, or Anno Hejre. I can never pronounce these things. I need to practice that. You note that this is a lunar-based system versus a solar system. So this is important, that one of the relative dating techniques we have to think about is simply marking the passage of time using natural cycles and astronomical, not astrological, astronomical phenomenon, right? Including the movement of the sun, the movement of the moon, have been used to track the passage of time. So these are methods that we can use. The Buddhist system, and the Buddhist system varies significantly depending on where we are in the world, and part of this is because of how Buddhism is applied, is practiced, and understood in other parts of the world, plus other cultural values and links, is a lunar solar system. So it uses both the phases of the sun and the moon. It has different types of months. I ended up in a rabbit hole this weekend researching this a bit more because I wanted to learn some more, and I was like, wow, there's just so much here. And then depending on where you are in Southeast Asia, there's different terminology that's used. It's really exciting. It's a neat system. But what this shows you is that we have to be cognizant of this, right? So when we're reporting dates, that we need to think about who our intended audience is, and we have to be aware of the context in which we're reporting the dates. So if you're doing Islamic archaeology, for example, it's more common to see the dates reported using both the Gregorian calendar based on the techniques that are used in absolute dating, but you may also see dates reported based on the Islamic calendar as well, right? So the lunar system, which is really, I think, important and critical. So we just have to be aware. The number one critique I have is inconsistency. Ultimately, I like to think that I have enough skills that I can read and figure out what system of dating that they're using, right? How they're representing dates. Again, in archaeology, BP, or before present, is the most common annotation that we see, at least in the last decade or so, right? But if you're inconsistent, if you're switching between BP and BC and AD and calendar years and all these, then it gets really complicated. So what I always tell students is just be consistent. As long as you're being consistent, you can lead the rest of us along your path, right? That's what's key. Okay. We're going to talk about this more next week, but I just wanted to mention this up. But of course, our primary focus, our primary concern in archaeology is always going to be context. So when we're dating something, particularly material culture from an archaeological site, we must be aware of the context. If we have concerns around the context or the security of the context of the material we are dating, that is going to then continue to increase or amalgamate, or however you want to think, or snowball right into effect that you'll basically get a whole bunch of compound errors that can result of, right? So if you have insecure context, you get dates. Those dates then can become challenging to interpret because of issues with that. I'm very passionate about this because this has been the bane of my existence with one of my archaeological sites in Tanzania. We found some fossil human teeth. We found them, however, out of context. We didn't find them in the excavation process. We found them in the screens, which meant that when we went to date the site, we don't have secure association between the materials we dated and the material culture we're hoping to date. There are some questions around it. Now we know what layer it comes from within the site. The samples for dating were taken from the same layers, but then we had problems with the dates themselves. They don't seem to be aligning. We have some inversion. We have some other issues based on our stratigraphic understanding of the site. And ultimately, in my opinion, it comes back to we're trying to date not directly a particular form of material culture, in this case, fossil teeth, but we're dating by association. And because the association or the context is unclear or is problematic for a number of reasons, the dates themselves then become a problem. I have a specialist who's been doing the dates and been doing the dating, and she has been trying all these different ways of fixing the dates, of trying to address with contamination issues. And ultimately, my conclusion has been, and it's not favorable by other members of my group, my research team, is that I don't think we can date these. We simply have to state that we can't. We have done our best, but there is no way, because again, the security of context has been lost. And because we're not confident in that association, really spending all this time, money, and other resources, so really time, on this exercise is kind of futile. We need a different strategy, right? That's why I'm not a co-author on the one paper about the teeth that went out, because I was increasingly becoming disillusioned with the interpretation of the results, because I knew the results were problematic, because it all went back to the problems with the context. And sometimes that's just the way it is in archaeology, baby, right? We weren't anticipating finding fossil human teeth. And it just so happened they turned up in the screens, right? So be it. Okay, so we need to know where the dated material came from. If we're not directly dating material, if we're dating by association, we have to be confident in that association, and that's going to lead us to stratigraphy as being really critical around controls around excavation, and also contamination. And note that largely speaking, contamination is only a problem with absolute methods. So we'll talk about it next week, because we'll talk about how methods like radiocarbon dating have protocols in place to address the contamination issue. So contamination is not inherently a problematic issue if you consider it, right? If it's one of your assumptions, if you automatically assume that your sample is contaminated, there's steps we can take to address that, right? If we know there's problems with context, then we can address that right away. And actually, if we would have right from the get-go addressed this more rapidly, had a dating strategy in place while we were excavating, we would have had far fewer issues than we have now. Okay. Another issue we have, again, this is often with chronometric methods, is we will obtain one date. We'll get one radiocarbon date per site. We're so excited because we're like, this changes everything. How many of you have seen the news about the new footprint site, by the way? United States, right? How exciting is this? So there's a new, it's new to the public, newly disseminated about. I hadn't heard about it before, but I'm not big in Southwestern United States archaeology. I don't know much what's going down there, but I keep an eye because it's pretty cool stuff. So they have a site where there are fossilized footprints of clearly humans, and they've been able to directly date the sediment and other material culture with that site to definitively establish humans in the Americas prior to the ice-free corridor, prior to last glacial maximum, prior to the Clovis, right? What does this do? Of course, this reinforces indigenous perspectives that they've always been here, but now we have concrete, at least from the archaeological community, evidence, data, dates to support this. Why are the dates for that site supported and so widely accepted and celebrated? Because they don't just have one date. And these dates have been verified using multiple methods. So if you're reading something, particularly when it's published in very big media reports and stuff like that, and they're focusing on one date, go to the original research articles and make sure that it's not just one date, but that they've come to that conclusion on the basis of several dates, right? Because otherwise it can be very difficult to assess the accuracy and precision of those dates. Remember, we talked about that those are major limitations with these kind of methodologies. Remember as well that we need a degree of error. Again, this is associated with chronometric methods. We're going to see lots of examples of this next week, but I just wanted to present this right up the upfront. And how concerned we are about the range of error is going to depend on scale, right? So I've mentioned this already in this course, right? That if we're, for example, my part of the world, East Africa, working on modern human origins, I have sites that could date back to Oldowan even. We don't have any Oldowan sites in our area. They're all Acheulean, and we have Acheulean sites that date to 1.8, 1.7 million years ago. So a plus or minus range of 10,000 years when we're dealing with the scale of millions of years isn't a big deal. If I got a date back from a lab and they said, oh, that Acheulean site is 1.7 million years plus or minus 10 years, I'd be like, what sort of witchcraft are you doing? Because that doesn't sound like a range of error that normally would be associated when we're dealing with a massive time scale like that, right? So we would have to have some sort of dialogue around that. Maybe they've refined the methodology, and that'd be great. I'd be like, oh, that's really exciting. But I'm not expecting that kind of precision on a time scale that big. Now, if I'm dating something in what we might call the more historical period, right, then I would expect to see a smaller range of error, right? If they're like, oh, it's 1,000 years old plus or minus 10,000 years, well, that means it could have been made today or 10,000 years ago. That's not very accurate, right, on that scale. So scale is everything. Okay, so I have some slides. Again, many of you have seen this before. I just thought I'd throw in here that this is one of the ways that we approach accuracy and precision in dating techniques, right? That we're focusing on either how close it is to the chronometric age of the material we're dating or dating by association, right? One of the questions I often get from students is, how do we know what the real age is? That's usually where relative methods come in. They give us an idea, a ballpark, if you will, of what we expect to see, right? So we have to use other sources of information. This is why, again, one date is no good date. We cannot assess accuracy without it. And then precision, right? And so precision is usually related to the limitations of both the scale of what we're trying to date and also of the methodology itself. I often show this stylistic representation. This is from a great article on radiocarbon dating by Petit. It's actually a book chapter, and it's the Handbook of Archaeological Methods, and I love this. And I gave an explanation before time. I'm not going to go through this. But what this shows you is how we can make these assessments of precision and accuracy in kind of a stylistic form. I've also given an example of how we interpret dates using this. Again, what I've already illustrated regarding scale and scope. This figure elaborates, as I state in the notes, on this idea of context and being confident in the security of that context, of those associations we're making. Because this is what I think is actually the major issue we have in our Tanzanian site, is that I think the reason why we don't have good security outside of it being found in the test pit is that I think that because of the natural formation processes of the site and the changes that have occurred naturally over time because of water movement and erosion, is that we have something called deflation happening. And we also have high mobility through the unconsolidated sediment, which means basically the dirt hasn't been packed very densely. So small things can move through as people trample on the surface, as water moves through. And I think what's happened is that objects have been moving up and down in the sediment. And so that's impacting it. So that's why we get dates that are really old high up in our stratigraphic sequence, and then dates that are really old low in our stratigraphic sequence, and then in the middle a whole bunch of random dates all over the place. It's because I think we basically have massive blocks of sediment where everything is mixed up. Right? I seem to be the only person, well, not the only person, I seem to be one of the few people on my team who think that's what's going on here. So we have some fights about this. Some people are like, no, we have really clear strata, we have really clear what's going on, these are secure contexts, and I'm like, yeah, no, I don't think so. But this is where also archaeology gets complicated, right? Is how we interpret the record itself can vary. So what this is meant to show you is our little happy faces here represent potential samples we could be taking from an archaeological site. In this case, they're both coming from the same strata, right? So let's say we want to date this pit that's been cut down, and we can see it in this cross section of our archaeological site. So these are supposed to represent the layers of strata or the sediment that's built up in the site over time, right? And so we've taken these two samples, one from within the pit and one from just outside of the pit. And what it's talking about down here is that both of these samples are going to give us imprecise or inaccurate, potentially measurement, or sorry, I shouldn't say imprecise, potentially inaccurate dates for this feature, for this pit, and for that strata. Because in the case of our topmost one here, what we have is a sample from a younger sediment. So we know this through the law of superposition, moving down into an older sediment. So this is going to make this layer appear younger than it is. Whereas this happy face is coming in from a sediment that the pit cross-cut into, which means that these sediments have to be older than our pit feature, because you can't dig a hole into air, right? You need ground, so they dug down into it. And so what this means is it's going to give us an estimation of this layer of this pit being older than it actually is. So in this case, we would get one date that's too young and one date that's too old. Neither date are going to accurately reflect the true age of that sediment. Right? Well, how do we figure out if we have residual samples or not in archaeology? Well, that's where the field work comes in, right? And this is the information then we need to share with our specialists, right, our analysts in a lab environment, so they know what the potential issues may be, right? Because if I'm expecting this layer to be 5,000 years old based on our other artifacts found in it, and I get a date that comes back and says it's 15,000 years old or it's 500 years old, then I have to figure out where the problem lies. And one of the where it might lie might be that the samples themselves are contaminants into that strata, right? That there's not a lot of security of the context. Does that make sense? We can go back to this once we look at stratigraphy a bit more. Okay, let's get into methods. Like I said, as all archaeological research or analysis should begin with description, all dating begins with relative methods. Right, so you can see that even talking about chronometric methods, talking about samples that we're taking, often are going to be linked back to the most important dating method that we have, which is that of stratigraphy. Right, and stratigraphy feeds into a number of different methods, as we'll see in terms of looking at biostratigraphy. We can talk about lithostratigraphy, etc. Okay, so we need to correlate a number of different sample types and other sources of information about where the site dates in order to get an understanding of what the real age could be, right? Remember that we're not going to get from relative methods necessarily an actual calendar date. We may simply be able to say that this site that we're currently working in, based on the material culture present, is older than this other site. And that might be all we can say. Or we might be able to say, we know that the site must have been occupied prior to this date because, and so we'll talk about terminus ante and terminus, I can't remember what the other one, terminus quo ante, well, anyways, it's in the notes. We'll get there in a second. I don't use that terminology a lot. It's like, we don't use that a lot in East African archaeology, but it's commonly seen. Okay. So what are the main dating techniques that we use that are relative methods? Well, most of them are just forms of chronological sequencing, again, establishing these relative sequences of things that are older than and younger than within a site, And then we can often use that information to correlate information between sites in order to establish broader regional chronologies. We can do dating by association itself, right? This often involves the use of things that we call index fossils. Sometimes it can be of key types you often hear, right? So in regards to dating people's movements in the Americas, one of our type fossils, of course, are Clovis points. That gives us, they've been firmly dated in several contexts, so that gives us a pretty good understanding. So if we find a Clovis point in a site, that gives us an understanding of kind of one of the potential ages or dates in which the site could have been occupied. We have some that are kind of what we call calibrated relative, and it's because they require some chronometric methodologies or techniques in order to validate or confirm the dates that are obtained. And then, as I mentioned, we have this kind of idea, this kind of broader conception of using the terminus system. This is where we have objects of a known age that we can use to kind of anchor our relative dating of a particular site. And coins are usually a classic example of this, because throughout history in many parts of the world, on our money, we have decided that it's important to put the date on it. And thank goodness someone decided at some point to do that, because it's been extremely valuable in dating sites throughout the classical world, right? Okay. So let's look at this terminus antequem and terminus postquem, and I apologize, I'm probably pronouncing this wrong. I never took Latin in school. So when we use this, I just use this to illustrate it, that when we talk about terminus antequem, we're talking about the time before which, right? So what does that mean? The latest possible date that something might have happened at the site might have formed, or an item, and usually in this is the archaeological context, an item was made in use or deposited. So I use the example here of a burial with a coin in it, or not just one coin, but 4 coins. And so we have a barrel that has 4 coins, 1835, 1837, 1840, and 1849. So our terminus postquem for the site based on those burials would be the latest date that we can establish with certainty, which is 1841. Okay, so we know that the site must have been made, must have been formed at least by 1841, because we have an object dating to 1841 in this site. Okay, it doesn't mean it couldn't have continued after that, but we know that that is definitely one of the last dates that we have known that the site could have been occupied in use. And then we have the limit after which postquem, so the earliest date that an event might have happened or an item was used or deposited. So the example I gave in here is from Wikipedia is about building foundations being demolished, and then a city was constructed or a city wall was constructed. If we know the date the wall was constructed, so in this case 1650, then everything that was built before it must have been demolished before that date, right? Or must have been present before that date, right? So it gives us an understanding of the kind of temporal boundaries of that particular site. But this only works when we have a known object, date, feature that we can associate the rest of our material with. Does that make sense? So I have very little experience using this because almost every site I've worked on hasn't had material culture that has dates on it, right? Okay. Stratigraphy. This is, as I mentioned, the most important dating technique we have, because it is the first step, regardless if we're using, even if we're using radiocarbon dating or ESR or OSL or thermoluminescence or whatever method we're using, it's all going to come back to stratigraphy, because stratigraphy is how we obtain the context of materials, right? That's part and parcel of where finds are found, right? So we need to start with stratigraphy. So I just want to review some of the basic principles, right? The key thing then means that when we are excavating our site, so right, thinking back to research design, we have to begin by thinking about how we're going to excavate our site in a way in which we will have control over stratigraphy. And there's a number of different ways we can do this. They all have, again, their strengths and limitations. This is not a methods course, so we won't talk about excavation, but it's just important to note that the better control we have over context at the point of excavation, the better control we, in theory, will have over dating that site itself, particularly because it will allow us to date by association, right? We don't need to get dates for every single individual piece of material culture in a site if we can have samples that have good association with other material culture, right? So we can date by association. So I've provided you with a bit of background just for those of you who are not familiar with stratigraphy. Again, this is something that varies a little bit in terms of how much we engage with each year in archaeology. Some of us teach it more than others. As I just thought I'd share some of the basic principles of stratigraphy that we use that are particularly relevant to dating, right? So we have the law of superposition, that layers of strata, of sediment are successively deposited one after the other, right? So this is often referred to as like the layer cake or the sandwich hypothesis, right? That if we want to date a cake and understand about how the process it took or the passage of time, right? We begin with our plate that we have our cake on, right? So we have our plate at the bottom. So that had to exist before the rest of the cake was made, right? In order to put it on top. You're not going to make a cake and then go out and make a plate to put your cake on it, right? So we begin with, usually in the case of the archaeological record, we'll talk about bedrock, right? Which is the foundation in which all the other sediments have been subsequently deposited, right? And then we have our first layer of cake, and that's going to be our oldest layer. And then as we put our layers of cream cheese icing or maybe some fruit in the middle, each subsequent layer is going to be younger than the ones that precede it. So that's simply what it says, is that layers are deposited in a sequence on top of each other, one after the other. And as a consequence of this, the layers on the bottom are older than each subsequent layer, okay? The law of original horizontality argues that these deposits are laid down horizontally within archaeological sites or within sediments. Now note that the application of the original principles of stratigraphy as written in geology don't exactly work in archaeological context, and we're going to talk about how that plays out in the Harris matrix in a moment here. But it acknowledges that deviations can occur, but typically we go into a site assuming that the deposits we are excavating were originally laid down in this horizontal manner. And if we're seeing evidence that suggests otherwise, we need to be aware of that because it's going to impact our ability to date by association or date using stratigraphy. Okay. Principle of association, of course, this is extremely critical. The idea that items found together in the same deposit are of essentially the same age. Essentially is the key word here, right? That they are close enough or approximate enough in age that we can consider them to be a unit. This isn't always the case, right? But if it isn't, then we need to investigate why. Principle of reversal, that there is circumstances under which deposits will be removed from the site and redeposited in a reverse order. We often see this when people have dug pits, because if you ever had to dig a hole, for example, to plant something, you often will dig it down and then you'll just take the sediment that you're removing and put it right beside your hole, right? So now you have older sediments on top of younger sediments, right, through this process of reversal. So we have to look for indications of this. And then also of intrusion, and so I mentioned this when I showed the residual and invasive deposits, right, that in order to cut down through into sediments, those sediments that you're cutting into must already exist, therefore they are older than the event that led to the intrusion, right? And this can be either a cultural process of people causing intrusive deposits, but also there's many natural processes such as rodent burrows that can cause this as well. Haley, when you were at Bodo, did you encounter any intrusive deposits?
Yeah.
So many, eh? Yeah. Yeah, so the Bodo archaeological site is in sand dunes, which is also a mobile kind of sediment itself because the sand can move over time and stuff, but it's fairly fixed and stable now, which is why people have lived out on it or there and engaged in activities there at various points in the past. But it tends to be that environments that attract people also attract animals, and particularly the dunes at Bodo have attracted so many rodents. And so you find tons and tons of burrows through the archaeological site. And they're disturbing the context, right? So we've found older projectile points, for example, in burrows in younger sediments because the rodents have dug down through, and then as they're moving the sediment out through, they're moving projectile points from older deposits in the site up into younger ones. And then vice versa, you can also see younger deposits then intruding into older ones as well. So intrusion is very, very important in archaeology. It's very hard to find sites where there's not some sort of sign of disturbance. Roots, so many roots, right? Dig down in and cause intrusion. There's lots of examples of this. Okay. So we have to be aware then that, again, in the archaeological record, that we're dealing with not just natural processes, but also cultural processes that can create these kind of what we call oddities in understanding stratigraphy within the site, right? However, these oddities are actually useful for us, particularly if they're cultural associations, because they can tell us about, again, whether or not the site is in primary context or if it's a secondary context. Again, if there has been disturbance that's occurred, and can tell us these other things. So this is a very famous image of some work that was done by Mortimer Wheeler. Wheeler gave us the Wheeler box method, which is one method of vertical excavation and horizontal excavation that preserves strata. And in particular, it focuses on vertical stratigraphy versus horizontal stratigraphy because of the use of what are called bulks or walls between various units. So you can see the stratigraphy regardless of where you are. And what's interesting about it is it shows and illustrates some of the examples we've talked about, right? So, and there's examples of a Harappan seal, at the tops of dated coins. We have various pits, such as a modern tree pit. We have an ancient spoil pit or midden. We have one that's even older spoil pit because it's in a lower strata. We have house walls, right? So one of the things we have to do as archaeologists when we're excavating is not only have control over stratigraphy, but also document it as well, right? We want to record the context in which our samples are coming from, because this will assist us in interpretation, right? Because what they're trying to show here is that while all the samples were taken for dating from approximately the same depth below surface, right? They're the same level or the same what we call excavation level within the site, they come from different contexts, right? So this one is going to be much more recent, right, at 1910, then our coin is going to be at the 2nd century AD versus our Harappan seal dating back to the 3rd millennium BC, right? So even though they're all from the same, or what we would consider the same depth or the same level within the archaeological site, they're definitely not from the same strata, and they represent different events in the history of that site. So one of the key figures then that really started to advocate for kind of challenging our application of a geological perspective of stratigraphy to understanding dating in archaeological sites is that of Harris. And so Harris in '89 wrote an article and developed a methodology which we now refer to as the Harris matrix. And I love this method, and part of the reason why I include this, and again, this is my own bias coming to play, is that an article I'm writing right now about some video games, we're using the Harris matrix to show different versioning of video game code as it's changed over time, because we're kind of treating an assemblage of artifacts in the same way as without having a site as representing an archaeological site. So we want to look at change in the code over time. And so we're using the Harris matrix to represent its various forms as they've altered. But what this argued, again, is that because of site formation processes, because of how archaeological deposits are different from geological deposits, we need to expect and anticipate these kinds of changes. But he also wanted to recognize that when we look at strata or the deposits within archaeological sites, what's also important to understanding some of the different processes that have impacted the site is acknowledging that there are interfaces that also exist between the strata, right? Now in geology, they talk about contacts, but interface is meant to get at this understanding that's not just cultural or natural processes, but cultural processes that can shape how strata are presented in archaeological sites, right? So they talks about how features and feature interfaces are actually special classes of deposits because explicitly their connection with archaeological or human activity, So what he wanted to do was not only continue to capture sequence of stratigraphy, but wanted to capture the sequence of deposits, right? So we can use the various principles and laws that have been established, but also represent the kind of process of deposition that occurred as captured through the interfaces. So we wanted to build the interfaces into these stratigraphic sequences. And so we do this using boxes, basically. And he has a bunch of different symbols. I'm not going to go into what they mean, but essentially it's just an alternative way of representing the sequence of deposition, potentially of erosional events, of cultural events that shapes an archaeological site. He also outlined that there are three principles. Oh, sorry. Why did the screen turn off? Oh, did it time out? It timed out again. And I was mucking around with this earlier. Oh my goodness. These smart classrooms are going to be the bloody end of me. It worked fine before, right? We just come in, plug in our computers, and it would just show until we're done. And now they set these timers, and I don't know how these timers work. I can't find the timer. I want more time. No, give me more time. Come on. I can't control the projector. Oh, it's coming back now. I ran the place this would not be happening. Okay. Have to remember to touch the screen every once in a while. Maybe I'll just set a note for myself. Every break, touch the projector screen. Okay. How long had I been talking without you folks seeing the screen? Just like a minute, maybe? Just Harris? Okay, good. Okay. That's what I was talking about before. There we go. There we go. It's all here in the notes. Here's the notes I'm talking about now. Huzzah. Okay. What he also argues is that when we interpret stratigraphic sequences, we're also actually carrying a series of assumptions with us that both reflect the laws of stratigraphy, but also, again, kind of capture the relationships between the various strata and interfaces that exist in archaeological sites, right? That it is not just an objective tool, but there's subjectivity that's built into it. So one of the relationships that we can have is that there's no direct stratigraphic relationship between the units, right? This can happen under certain circumstances, that we can have superposition, right? That one layer was deposit or strata was deposit on top of the other, or we can have one where there's a correlation of stratigraphic units. And correlation is often when we're looking at relationships of stratigraphic units within one archaeological site and attempting to make a connection with those found in other sites or other parts of the region. And so we have different, as I mentioned here, graphic conventions for connecting various boxes that are meant to represent the various interfaces that are present. I also want to note that in archaeology, we approach defining stratigraphic units or deposits. We can approach it differently than purely from a geological perspective. Often when we think about defining a stratigraphic unit, what people's default reaction is to think about it from the perspective of lithostratigraphic units, or basically the principles of the dirt or the rock or the minerals that are present, right? So this includes things like the color and the texture and the sizes of the sediments that are present. And many of you who've done archaeology, you might recall when we do the geoarchaeology lab, we have you describe sediments using this various terminology. That is only one way in archaeology of defining a stratigraphic units. We can also have biostratigraphic units, right? And that's actually leads into more reading for this week. Essentially what they're kind of arguing is that there are biostratigraphic units that relate to microorganisms, right, in the assemblages at the site. We have ethnostratigraphic units. This is one of my favorites. We use this in Tanzania because we have type fossils, right, or we have projectile point, or sorry, not just projectile points, but we have lithic tool and lithic artifact types that we associate with particular chronological periods, right? So we have the early Stone Age, and there are characteristic tools associated with the early Stone Age, right? We have the earliest part of the early Stone Age, the Oldowan, right? And actually that's not even the oldest anymore. We now have a date, or we have a technocomplex that predates the Oldowan, but that's a whole other story. We have a Schulian, right? So if I see an Acheulean hand axe in my archaeological site in East Africa, I know that the site has to be at a maximum of 1.8 million years old. It could be younger than that, but so far, globally speaking, we have no Acheulean hand axe sites that have been definitively dated prior to 1.8 million years ago, right? So I can define units on the basis of presence of type fossils or indicator fossils such as these, right? And we use type fossil, but really we can use any sort of kind of material culture that is appropriate or relevant. So some parts of the world, the sequences or the seriation of pottery, for example, is so well known that, yeah, you can look at a pottery and be like, yeah, that was made between this time frame. Nope, this has this decoration. It was dates to this time period. Glass, particularly here in North America, we can really do that quite effectively, get a good understanding of, sometimes even within a couple of years, when a glass vessel was made. And we can also have chronostratigraphic units. So those that are usually developed by chronometric dating techniques, right? So we can get a good, an example of that would be like a layer of volcanic ash, right? So if we have a volcanic eruption, we date that eruption at one part of or that ash from that eruption at one part of the world or region, and then we find that ash elsewhere in the region. We can date by association, right? We know, okay, this is all from the same eruption event, right? So Mazama ash is something we find here in North America. Mount St. Helens is a more recent one. You can think about in the classical world, the eruption of Mount Vesuvius. There's been discussion about using the eruption of Mount Toba, which happened around the time of the, Mount Toba was 2.5 million years-ish, right? Or was it 1.8? I can't remember which event, if it was the old one or Schulian. They're arguing that it kind of is associated with that shift. I think it's 1.8 is when Toba erupted. Anyways, it was one of those super volcanoes in the past that when it erupted, they think created potentially like a nuclear winter across most of the southern hemisphere. And so they think that that drove human evolution. So if you find volcanic ash and it can definitively be linked or correlated to the Mount Toba eruption, then we now have a known chronostratigraphic unit, right? Okay. So I wanted to give you an example of this. Again, for the sake of time, I won't go through it at length, but I just wanted to show you a little bit about this process of using the principles of stratigraphy and the Harris matrix to understand the sequence of deposition and cultural events within an archaeological site. So here's a generalized stratigraphic profile that I drew using MS Paint. So the first step we need to do is assign some sort of designation to our various layers, right, or strata, but also to our interfaces, right? And so in this case, just for the sake of kind of keeping things straight, because if I wanted to use numbers, for example, then you might think, oh, one might be the youngest, or is it the oldest because it's the first one? So I used letters because to me, letters are less confusing, right? Because letters don't have to be in alphabetical order, right? They're not inherently, like A isn't inherently associated always with one, right? But I can use whatever I want. And sometimes in sites, we don't even use letters. We might use actual terms, right? But I still want to first identify them so that we can talk about them. So I just went through and I randomly assigned all of the layers and interfaces letters. And then what I've just done for simplicity's sake is I've described what I think those represent, right? So either a depositional unit or an occupation, a cut or a fill, or in one case, other objects that were found within a fill and within a cut. So the rocks as well. Okay. So I've arbitrarily assigned these layers. I think they might be useful. I've probably used other methods for establishing these layers based on observable physical properties of the various strata, of the various interfaces in the field. Those aren't captured here, but presumably they would be in my notes. The next thing I need to do is figure out the sequence of deposition. I should have had an animation, so I didn't just give you the spoiler of what their answer is, but let's walk through very quickly the process of how I established this. While using the principles of stratigraphy, I began, and I like to do this because I'm an archaeologist, I like to begin at the bottom. I like to begin at the oldest, right? Because to me, I know that the layer that is on the bottom has to be our oldest, right? Because everything else following the law of superposition has to be buried, or has to be not buried, but deposited on top of it. And so the layer that is on the bottom, aside from the bedrock, which is our base layer in which all the sediments have been deposited, is D. So that is going to be my first. Then I have to look and see, okay, what came next? So my next instinct might be to look at the next layer here, which is C. But what I see is that cutting into D, right? Because remember, following the principle of intrusion, that G, the interface G, must have been cut down into the sediment before it could be filled in with H, right? So our first sequence of deposition is first D, followed by an intrusive cut, represented by G, which is then filled in with H I know that G and H must have come before C, because what is C doing? C is superimposed over those deposits, right? And then I can follow through in the same principles with each of the following sequences, and that gives me this basic sequence here. This is what it would look like in a Harris matrix. So much like when we're drawing a stratigraphic profile and stuff like that, we're going to put the oldest at the bottom. So I put D at the bottom, and then I've created this linear sequence up through, representing not just the deposition of units, but the various interfaces that exist between them. I could have been more specific. I could add this interface as well between C and D and A and C, but I didn't get that complex. I just focused on more of the cultural ones. But this was just meant to be a simplified one. In some cases, Harris matrices can represent, so for example, let's imagine we had, let's see if it'll let me do this, shapes, squiggly line. Let's imagine we had another pit here that was cut in, okay? And we're going to call it, so H-I-J, so we'll call this J, text box, J, right? So we have this new unit in here. So in this case, where does J fit into our depositional or into our stratigraphic sequence or into our Harris matrix? Well, actually, let's just deal with into the sequence. So let's start. So we know that J, so in this case, I haven't labeled the cut, but we're just going to label the whole pit as one feature. J is present in the strata that we're calling D, right? So D must have been first, so we know that J has to be younger than D. But is J younger than H and G, or is it older? Or am I asking you a trick question? Exactly, we don't know that. In this case, all we know for sure, based on using the principles of stratigraphy, is that J must be older than D because it cuts down into D. It must be younger than C because it is below C, but its relationship to H and to G is unclear. So in that case, what we would do is we would create a branch or a bracket off of D. We would shift G and H over to the side a little bit. I'm not going to do it because it's going to, oh, here, let's see. Can I do it? This is going to take too much time. I should have just written this on the board instead of mucking around with this, but we'll just blame COVID. So what I might do is shift these over this way, right? To show that they are definitely in between the sequence of D and C. But then I would add in to the other side, paste, come on, copy, copy, paste. Oh, no, not you. Paste. There we go. And so we know that sometime around here, oh, can I edit this? Oh, no, I can't edit it. How come it won't make me say J? Anyways, you get what I'm getting at, right? Is that I would put J off to the side. And then I would just alter this line as a bracket and show that sometime, again, in between C and D, we have these two separate depositional and interfacing events, right? That resulted in pits H and J being established. Does that make sense? So I just wanted to show you that Harris matrices are not always linear, that they can capture the complexity of these relationships, because often when we talk about the stratigraphic sequence, is we fail to capture all these interesting intrusive events and reversals and all these other complex, often cultural events that occur. Okay. How can we use this in dating? Well, not as just to establish the sequence of what is older and younger than within one site, but we can then link the various strata from various sites in order to get broader regional sequences. And that's all this is showing you here. So this is chronometric dates, this is geoarchaeological analysis of the middle and upper Paleolithic record from sites in the Mesozoic period of Portugal. So what does this mean? Is that each of these represents a separate stratigraphic sequence from a different site. And what they found is that there's this discontinuity or this interface between stratigraphic units that can be found at all of these different sites. And looking at the strata that come before and after this discontinuity, they're able to then see what the relationship or the sequence of occupation of these various sites in an area are. We did something similar to this, not using stratigraphy, but using seriation and using beads in 206. So if those of you who have done the bead exercise with me, that's essentially what we did, was we were using data from various sites and comparing trends in artifacts versus trends in sediments or in strata to get at a regional picture. Okay. Stratigraphy is also important because often the strata themselves contain materials that we can directly date themselves, or we can date by association. It's not just land sediments that we can apply this to, but we can also do this with oxygen isotope records that have been derived from marine, either sediment samples or from ice cores. Okay, so in this case, this is a relative dating method where what we're doing is we're obtaining fossils that are microfossils of a particular group of organisms called foraminifera. And foraminifera vary in their shapes and sizes, but importantly from a dating perspective is in their shells or in their skeletons, which are made of calcium carbonate, I believe it's a calcium carbonate, is that it contains oxygen. And in the oxygen that it contains, we have two different isotopes that can be represented. And the isotope that is represented often reflects the climate, the temperature in particular, of that organism, and in many cases reflects varying densities of the water the forams were present in. Yes? What's right? Silica shells, thank you, that's what it is. I knew it had oxygen, I just couldn't remember if it was calcium carbonate, which would be CO2, thank you, or if it was SiO2, it's SiO2. Yeah. So the key is that we're measuring isotopic levels of oxygen in, the silica shells of the forams. I should know that because they're very similar to acortarps, which also have silica shells. So thank you. Always correct me if I make mistakes because I'm human. This is what happens. It's not a big deal. Okay. And so as I summarize here, that one of the things that we've noticed or we've been able to document is that in periods of glaciation, when water is being, ocean water is being locked up in continental ice sheets, what we see is a shift in the oxygen isotopes that are present in the foraminifera, right? That as greater amounts of water are locked into ice in these colder periods, we see an increase in the amount of oxygen 16. Right? In warmer or interstadial or interglacial periods, we have less water locked up in ice, more water in oceans, and it's a greater ratio of oxygen isotope 18 to 16. Okay, so just by looking at a shift, this can give us a relative understanding. Now, if we can measure the varying degrees of how much this ratio of oxygen of 16 to 18 is that we can then link it with the strata that they come from, because ice is deposited in the layers, much like sediment, and so that's how we can do this. And we've developed these sequences then that we now call marine isotope stages or oxygen isotope stages or marine oxygen isotope stages that allow us to get at relatively the age of a site, right? But this involves some fancy correlation between the marine isotope record and what we're seeing in the land record as well. So there's some wiggling, fudgy things we need to do. And we're going to come back to this. I'll explain a little bit about understanding these ratios when we talk about paleoenvironmental reconstruction a little bit more. Okay. Paleomagnetism is another one that's linked very closely with stratigraphy. We'll talk about this a little bit more. Again, when we look at environmental reconstruction. But what we know is that the rotation of the Earth's core plays a role in the strength, the intensity, and the duration, and also of the Earth's magnetic field. It also shapes where our positioning of our magnetic poles are. This is really cool, by the way, like our magnetic north is shifting and it has been shifting and we're tracking it. And one of the things that's really interesting is we're overdue, as it were, in geological terms for a reversal to occur. And every time we've had reversals, or not every time, but when we've had reversals at points in the past, they've been linked with like really key phases in human evolution. And so there's like a lot of speculation about what the next reversal will mean in terms of humankind because of what it means in terms of global climatic patterns and how it shapes our plant and animal environment. So it's just interesting to see. So a lot of people have paid attention for particularly of the shift between the Gauss and Manunama phase because that's linked with key period in hominin evolution, the rise of the genus Homo, shifting away from Australopiths, etc. So it's really cool when we look at these phases. But basically, the reason they were able to figure out that these reversals have happened, that magnetic north, its position has shifted, that the strength and duration of the magnetic field has changed over time, is that this record of magnetism is captured in magnetic minerals in various objects, right? And particularly from an archaeological perspective, when we talk about archaeomagnetism, and we'll return to this when we talk about pyrotechnology, is that in kilns and hearths and furnaces, what happens is that the magnetic orientation of these elements in the kiln itself and stuff becomes fixed at the point of firing. So what happens sometimes, and this is one of the ways that we've dated, particularly like really old hominin sites, is we can look at what the orientation of these magnetic particles are because they will shift over time. And so if we see, for example, a case where sediments where this has been recorded or lithic materials in the site where we have a record of this has changed, we can see this shift from what is called from normal to reversals over time. Right, so we can look at the orientation of these materials and get an understanding of basically which one of these potential periods it fits into, right? And if we have the stratigraphic information, then we can figure out where in this broader sequence it is, and then we can confirm it with chronological methods, chronometric methods. Another method that is kind of related, but also not, that relates to, again, how things change or shift over time, particularly in this case when they enter the burial environment, is amino acid racemization or amino stratigraphy. It's also called AAR. I'll admit this is a method that I haven't used very much. It's very similar to other kind of chemical or molecular clock methods that we use that looks at change in kind of the base unit of that material, in this case, the base of amino acids themselves, which serve as the base of protein chains. And so when organisms, living organisms, when organisms are alive, our amino acids have the L type, and just note that referring to them as living or death type is my own shorthand for this. This isn't actually what it represents. I capture it down here below. It's L, enantimomer. I'm not a biologist, I'm an archaeologist. I can say the names of rocks, but not of amino acids. But basically, it has a certain orientation, and then what happens is after that organism dies, is that amino acid shifts its orientation from an L form or an L type into a D type over time. And it relates to the twist that this amino acid has, and it's like a mirroring effect that occurs. So if it twists one way in life, then it starts to basically uncoil and shift into the other form through the process of a diagenesis in death, so change. We know the rate at which this occurs in many living organisms, and so we can calculate then the ratio or the proportions of L to D types to tell how much time has passed since that organism died, and presumably when that organism ended up in that archaeological record, right, in the site, therefore dating it by association. Okay, so how we prepare these samples, though, for this, how we extract the amino acids, how we interpret their shapes and stuff, requires the various stages, right? We then have to measure this as well using a number of methods. So AAR is kind of a combination of both a relative method and in some regards is almost chronometric because it requires quite a bit of interface with mass spectrometry or chromatography and stuff to capture and document the shapes of it. And it is also based on us knowing the rate at which this shift in L to D type occurs, right? If we don't know when that happens, we don't know essentially how much passage of time has occurred, right? The ratio only tells us that, oh, because there's more D type amino acids in the sample than in this other sample, it must be older than because this organism died before this other sample with more or higher L to D ratio. Does that make sense? So it's this kind of quirky, kind of in-between method. Okay. Talk a lot about this in 206. I'm not going to spend a lot of time in this day, of course, seriation, but I just wanted to remind you that yes, artifacts and ecofacts can be really important to us and valuable to us in establishing the relative age, particularly strata within archaeological sites or the relative site ages of sites in a particular region, assuming that we can apply our seriation to that, right? So I can't use, for example, the sequence that we have of projectile point, the projectile point typology here in Alberta to understand how old sites are in Tanzania, right? They are disconnected in terms of time and space, so that's not an appropriate thing. However, if I have a new site here in Alberta that contains projectile points, then I can use the existing Alberta point typology that we have in order to come up with a relative age for that site. And indeed, this is one of the most common ways that we date sites, at least initially, and this becomes really critical when we then do chronometric methods, because again, this will allow us to speak to the accuracy and precision of those methods. So for example, if I have a projectile point for my site that I know dates to 1,000 years ago, or 1,500 years ago, let's say we'll give ourselves a range of error, so between 1,000 to 1,500 years ago, and I get a radiocarbon date that says, oh, this dates to 1,200 years ago, plus or minus 100 years, that falls within the expected range, right, of when that site was occupied. So that gives us good understanding that yes, the projectile point and now the radiocarbon date we have both align in terms of being close to each other, that we can be confident that they both represent accurately the true age of that site. Okay. So we often refer to these as index fossils. I just want to specify again, this is just really important because sometimes I see students confuse this, that when we talk about a typology itself is not a dating technique, right? It is simply just when we're organizing material culture into types based on their shared attributes, whereas seriation is when we then assign value or time to those various categories, right? Okay. Then seriation has a number of limitations to it in terms of how we can apply it. So I already mentioned one, right, in terms of that they have to belong to the same cultural tradition. This can be hard to establish, and this is sometimes where we make missteps, is we make assumptions around whether or not a site fits into a broader cultural tradition, right? And sometimes what happens is we're building upon errors that have been made or assumptions that were made at the level of establishing a typology, right? So when we're applying a typology, we need to be critical of it, especially when we're using it in our seriation, right? We need to make sure that it is accurate, that it has been updated, that it still reflects what we know about change in artifact form over time for a particular region, right? So sometimes people will have to revise typologies because new information has come to light about how we should be arranging these into a sequence, or a new type has been found and we have to introduce that, and then we have to figure out how it fits into our overall understanding of change in style or form over time, right? Also, we recommend it comes from a restricted geographical region. Again, always back to this question of scale. What is appropriate depends, right? So here in Alberta, we have the Alberta projectile point typology that we use in seriation. But many of the types we find here in Alberta are the result of a much larger cultural tradition that has a much larger geographical region, right? And when I say cultural tradition, I mean like a kind of an archaeological cultural tradition, because it probably involves very different, but also, I don't want to say interrelated, but at least connected in some sort of way, different cultural groups, right, in the past, right? So we get into this weird, icky area when we use typologies about assigning points to people, but the idea is that people who lived in Alberta hasn't always existed with the territorial boundaries it has today, right? That's a colonial construct. People in the past had much larger regions in which they were engaging. And so we often use many of the same types here in Alberta that you see also in Saskatchewan, Wyoming, Montana, parts of the Great Plains, more broadly speaking, right? The Canadian-US border was not a thing, right, in the past. Okay, that's a much more recent past addition. So people could move freely throughout the Great Plains and exploit the same similar resources, come into contact with each other And so we see many point types, again, that we think of as being part of the Alberta point typology in other parts of the broader region as well. So what do we mean by restricted geographical region? Well, as archaeologists, we have to justify and validate how we're defining our boundaries in terms of time and space. We also have to remember that sudden changes can and do occur in artistic, cultural, stylistic traditions. So we see this sometimes. A good example of this here in Alberta is that there seems to be kind of a fairly abrupt transition where people go from using stone as a material in projectile points to using metal in projectile points. And it's not that stone gets entirely eliminated, but there's definitely evidence that suggests from throughout Alberta that once, in particular, like basically metals being used in pots and stuff like that, and kettles and stuff like that could be traded with colonial settlers, that there was a lot of desire for these materials. And we also see then glass projectile points be introduced and whatnot, right? And so there are situations like colonialism, right, the arrival of settlers into a region that can shift cultural traditions. There can be other reasons as that as well. Raw material sources might dry up, right? Obsidian, for example, sources we know, we have evidence of mines being abandoned in the past because simply there was no more obsidian present for people to exploit and use. They had to find other raw materials to utilize. And that then shaped the kinds of stone tool forms we see. So that impacted the typology, which then impacted the seriation sequence, okay? The other thing we need to think about is that we cannot make assumptions in the direction of stylistic change, okay? This is one of those like interpretive pitfalls that I think we fall into usually when we're starting off in our studies, because our culture has this understanding that things that came before us were somehow simpler, right? They were less sophisticated, they were less civilized, or whatever that word even means, right? And so what happens sometimes is people will see, and this happens in pottery, for example, is pottery will look all what we might call beautiful and complex. It might have all these different patterns and styles, and then all of a sudden it gets to be plain again. And we're like, oh, that's kind of boring. What's the deal with that? Right? Oh, well, this had to have come before these fancy designs, because people begin by making simple pottery and then it gets more and more complex over time. Why would they ever go back to simple forms, right? So we can't make assumptions about the direction of time or of change, sorry, because that can lead us down some interpretive faults. Yeah. Yeah.
But
Yeah. Right. And I always use the example in 206 of cell phone styles, right? That we saw, you know, I think I mentioned this last slide, giant cell phones, right? And then they got smaller and smaller. And then all of a sudden we were like, this is garbage. We want to be able to have good screens. And then cell phones got bigger again. And then we're like, oh no, they're getting too big. And then we had tablets. And now we have these weird phones that are somewhere between tablets. And now we want to bend our phone screens and we want to do all this other weird stuff. But we've decided for now, at least, that we like screens on our phones, because we don't want to use our phones to phone people, right? But that can change over time. Maybe we'll go back to the main phones and then we'll get rid of screens. And actually I have several friends who are moving back to good old style flip phones because they're just like, all I want to do is call and text people. I don't want all this other stuff. It's too distracting, right? So who knows? We'll see where this goes. And also access to materials also shapes this as well, right? So yeah, the war is a good example where a lot of materials were being pushed into military, commercial, productive activities and not into domestic consumption of goods, right? So that shaped then people's material goods that they had in households. And we can see this in the material culture of households versus, pre versus post-World War, right? So there's a lot of things that we have to keep in mind as we approach these things. Okay, there's different kinds of context based, again, on our understanding or assumptions that we make about change over time and how it manifests, right? So here's some examples here, but I want to talk about some other different methods. And sorry, I just added these in because I realized that I had some gaps. I listed them originally and then I didn't have them in the notes, so I apologize. We'll just blame the pandemic because it's breaking all of our brains. Okay, so I'll post these updated notes after class today. So dating by association, I've mentioned this a few times, that again, with good stratigraphic control, a good understanding of the stratigraphic sequence of deposition, that we can often date things by association. And again, this is where we see these methods intersect, because we'll use a seriated sequence based on known typologies. We can look at stratigraphy within a site, and then we can come up with some dates for things. And so it doesn't have to be artifacts. We can use ecofacts. Animal remains have been really great for this. Type fossils, index fossils. Here in North America, the presence or absence of various forms of megafauna in archaeological sites. So one of the things we see, for example, in bison is that bison change in size over time. They get a little bit smaller. Some of the early ones, Haley's like nodding because she's seen this at the Bobo site in southern Alberta. Yeah, is that bison got smaller. So we can look at even just the size of a bison skull in an archaeological site and immediately have an idea of if it's a younger or an older site. The bigger the bison skull, the older the site is, likely, right? So we can do this. We can look at change in landforms and features as well. And then environmental sequences. So I already mentioned that, like marine isotope stages is an example of using an environmental sequence on the basis of ocean and ice cores in order to look at change in sea levels over time. But we can also use pollen as well. This is one of my favorites. Can't do this in Tanzania because it turns out pollen doesn't look like it preserves very well on our sites. We've tried recovering it from our sediments. It doesn't work. But here's one from a site here in Alberta. And what we can do is that we can look at assemblages. So not just a particular type of pottery, but trends or environmental trends over time, how the environment has changed, to get an idea approximately of when a site was occupied, right? And so what this is showing you is that in our oldest sites, that most of the environment here in this part of Alberta, so this is a site that's located just kind of southeast of Fort Vermilion, is that we have the steppe tundra. And what these little wiggles are showing you is the relative frequencies of different types of pollen of different types of plants. So it's showing us what our environment looks at this time. So we can see stuff like pinus, for example. So pine trees is very abundant in the earliest phase, and then it starts to decline. It gets more abundant. And these relative frequencies change over time in relationship to each other, right? And so what we see is, broadly speaking, is a transition from a steppe tundra environment into an open boreal forest, and then into a boreal forest slash parkland now of today. And so if we get a pollen assemblage or sequence from our site, we can look then at the patterns of the different types of plants, pollen being a proxy for the plants that were in that environment. And we can get an understanding potentially of how old our site is. So if I get a sample of pollen from my site and it's dominated by things like Alnus, Biittner, and Picea, which are a bunch of different types of trees. Calyx is willow, populus is poplar trees. Picea is my poplar. No, not poplar. What's the other type? Not poplar, pine, and why am I blanking on this? It'll come to me tonight at like 3 a.m. I'll wake up early. Spruce, thank you. I think it's spruce. Yeah. Like I said, I know Salix is willow. All of these are like grasses and shrubs, basically, are all these different like chenopauds are grasses. Amaranth is other grasses as well. Brassica, that's the broccoli family, but there's a whole bunch of other plants associated with small shrubs and stuff like that. So anyways, so if I have an assemblage that has a little bit of these varieties, a lot of Picea, right? Not a lot of these low shrubs, that it's suggestive of an open boreal environment. If I'm dealing with a site that's also in the similar part of the world, right, same kind of geographical boundaries, that would suggest to me that it dates in the same time frame as other known assemblages of pollen in that area, right? So we can use pollen as a microfossil to establish this as well. And actually, we can do this with forams as well, because foraminifera shapes and sizes vary based in response to climate. And we can also do this with another material called, or another microorganism called acrotarchs as well, because they, their appearance in the microfossil record varies based on climatic change and stuff like that. And so we see some different genuses or genera that arise over time and fall based on these various climates. A dating technique, one of the earliest relative dating techniques that was used was something called fun dating or fluorine, uranium, nitrogen dating. And simply what this is looking at is the amount of fluorine, uranium, and nitrogen that's present in bones, okay? Older bones have higher levels of fluorine and uranium and less nitrogen. So again, we can look at the approximate ratios of these elements in the bone to give us an approximate understanding of how old the bone is, particularly and relevant to other bones in the same archaeological context, right? So this isn't necessarily good for comparing between sites, but it's really good for comparing bones within the same site, right? So before I send bone out for, let's say, radiocarbon dating, because I can date bones using radiocarbon dating, I may do FUN analyses on it to get an understanding to see if all the levels are very similar, so I can be more confident of their association with each other, right? Because bones lower in an archaeological site should have more fluorine, or in older deposits should have more fluorine and uranium, and those higher up in the archaeological sequence and the stratigraphic sequence should have less amounts of that, right? So we can use these to kind of correlate each other. The most famous example of this is the Piltdown site and of Piltdown Man. So Piltdown was supposedly a fossil hominin that was found in the United Kingdom. It was going to change everything we knew about human evolution at the time. We now actually have other pre-human humans, so early humans in the UK, but this was an early one. And one of the ways that it was debunked was they actually did fluorine, uranium, nitrogen analysis. And what they found was that not only was it not as old as it was reported to be because of the levels of the fluorine and the uranium, but also that it had been pieced together with several fragments of other fossils and also recently deceased primates. So not only was it fraudulent in terms of what they were purporting it was in terms of its age, but it was fraudulent in that it had been pieced together. So yeah, I said like the skull or the cranium part was human, and then the jaw was actually from an orangutan specimen, right? So they were able to then do subsequent analyses based on what the fun dating was saying, because presumably the cranium and a jaw from the same individual should have the same levels. And when they came out as markedly different, they said, okay, something's going on here. They did further analyses. This is the famous picture of the team doing their detailed investigation of this find. And what they ultimately concluded was not only was it, not as old as it was said to be, but that it was a hoax. And they were actually able to figure out that there was plaster parts. I know this says fragments of a chimpanzee jaw. It wasn't, it was an orang jaw. And then there's actually metal tool marks where you can see on the teeth where they filed them down in order to change the shape to make it look like this kind of ape-human hybrid. This was supposed to be, Piltdown was supposed to be the missing link, by the way, between humans and non-human primates. It was supposed to be, again, changing everything we knew about human evolution, but instead it was a hoax. And to this day, we don't know definitively who was the perpetuators behind it, but there's a lot of speculation that it was actually some of the people involved in its discovery and analysis that were doing this. Why they did this, we still don't know that either. There's no good record for this. Okay, most of what we've talked about, as you can see, and this is an issue that we have in archaeology, is that many of our relative dating methods are based on the preservation or the fossilization of organic materials, right? So this is why we like pollen, because pollen is quite resilient. It preserves in many contexts, but bone, not so much. So if we don't have bone in an archaeological site, now we've already greatly limited the kinds of methods we can use for dating. We can't use FUN dating. We have nothing to use it on. We might be able to use radiocarbon dating on other potential organic specimens, but how do we direct date things like stone artifacts? We're going to talk about this next week because direct dating stone is really hard. Why? Because some of the dating techniques we can use on stone will tell us when that stone was made, like formed in the natural environment. So how old the rock is, but it won't tell us when that person modified it. So we'll be like, oh, this is a piece of granite that dates to 30 million years ago. But humans weren't around 30 million years ago. Humans modified it much more recently than that. So it'll tell us how old the stone is if we directly date it, but it won't. An exception to this is a relative, and again, this is one of those weird relative / chronometric methods because it requires correlation and confirmation by chronometric methodology, but is obsidian hydration. So obsidian is a naturally occurring volcanic glass. It's highly preserved, or it's highly preferred by people in the past as, and actually even today, people who do flint knapping as a material. It's incredibly sharp. It's hypoallergenic. It's an amazing material. It tends to be very homogeneous, which gives it good properties for knapping. We'll talk about all of this in a few weeks when we talk about lithics. But one of the interesting things about obsidian is what happens when fresh surfaces of obsidian are exposed to the environment. So when we are shaping a stone tool, for example, and we are knapping it and we hit it, let's say we're using a flake technology, which is what we use with obsidian. You don't want to use obsidian as a groundstone technology. It's too brittle, it just turns into dust. But if we knap it, we create, and we open it up, we create a fresh surface that's now being exposed to the atmosphere, to the environment. And for some reason, obsidian is one of these minerals that still interacts with its environment, particularly regarding to moisture. And if that fresh surface is exposed to the atmosphere and to moisture for a sufficient period of time, it develops what we call a hydration rind. Okay? Sometimes this rind can be observed, depending on how much time has passed, macroscopically, but more often than not, this hydration rind is best identified using microscopic methods, right? So observing it under a microscope, and that's what you're seeing here. So essentially what this rind forms is, again, is the interaction of the volcanic glass with the moisture that's in the environment or the amount of water that's present. And so the thickness of the rind correlates roughly with the amount of time that that surface has been exposed and uptaking water. So the idea is that you can measure the thickness of the rind, plug it into the calculation formula, and it will give you an understanding of how long it's been since that fresh surface was initially exposed to the environment. Okay? Why it's kind of an absolute method is that some of the methods that we use, again, to determine and to kind of calculate how much time has passed are dependent on other methodologies, right? So we need to know what the environmental conditions were like, what the moisture levels were like, what the chemical and mineralogical structure of the obsidian is, because that's going to impact the uptake of water into it. And also obsidian, in many cases, already has some water content intrinsically in it, and that can impact the hydration rind as well. So it is a method that's used. I don't see a lot of widespread application of it, however. It's also to see the rind as well. Also, again, it's a destructive technique, and people don't always like to do this. Or at least to see the thickness of the rind or the weathering surface, we can see this. This image here is from a study looking at this and calculating some of these rates. And what they actually did was, rather than use obsidian, so naturally occurring volcanic glass, was that they used laboratory glass for this experiment, because then it has a known composition. They can control the temperature. And so this is how then they used to calculate then these, or generate these formulae that can then be used for archaeological specimens, right? So we can do control studies of this process in a lab environment with human created glass of known composition, again, in set environments, and then we can use that to apply and generate our understanding of this process in artifacts or in obsidian in the wild, as it were. Does that make sense? So again, it's a neat method, but it has a lot of limitations and challenges associated with it. Okay, so I did give you some specific discussion questions for this, but before we talk about the paper, I know we don't have a lot of time here, and we'll do the exercise next class, is when we're talking about the methods, and this is really critical for next week. Again, remember, we don't have an exam, right? So I'm not going to examine you on these. I thought about doing it, and then I was just like, oh, hell no. Because so much of this would be memorization, and that's just, no one likes memorization, right? Except for people who are really good at memorization. Not me. My brain is totally a sieve these days. It's just thinking about, again, what are the basic principles of the method, right? So that's what I've tried to present here, are just some of the basic ideas of how does this method work. Of course, what material it can be used on, so what its application is for, what material we can use to sample, right? Because not all archaeological sites are going to have all these materials available for dating. And then also thinking about the effective time range. So I didn't report that in the slides, That's something we'll look at in that table when we come back next week. So in our brief remaining time here, I thought we could talk about Grund, and we can revisit it, and we will when we talk about environmental reconstruction, is looking at, and I picked this one just because this technique is so cool. I thought it was so neat, and also, as I mentioned at the top of the class, that it kind of originated by answering some different questions, and then the archaeologist thinking, oh, what else can we use this data for? Okay, so thinking about what I presented to you in terms of the discussion reading tips, or the how to tips to approach the readings, these are the discussion questions I thought of for this paper. And you'll notice that they are not very specific, they are more broad, right? So kind of mirroring the approach I want you to take to all of the readings in this course. So what is the main objective of the research presented in the Grund et al. Article? Or Grund? Maybe it's Grund. I don't know, Grund, in this article for the Journal of Archaeological Sciences in 2014. Coming to us from the University of Wyoming. Also selected because this Hell's Gap site is really cool. Again, Hell's Gap points are found throughout kind of the Great Plains region as well. And we have some really nice chronometric dates for those points. So to me, it was very interesting that they were looking at another way that we could potentially date archaeological materials. So what's their goal in this paper? What are they trying to do? So let's think about what are our big questions in archaeometry. Are they trying to source a material? What are we talking about? Yeah. And then ultimately, what are they hoping to do with this method? Date the site, right? So this is an example of dating, right? Although this, again, isn't where they begin. They begin with paleo-environmental reconstruction, which is one of the other things we can do through archaeometric research. And then they suggest that we have another potential relative dating technique. Yes?
Yeah, it kind of seems like they started off with the thing, and then that wasn't developed enough to be exact.
Yeah.
That's kind of where they started to see the validity.
For sure. Yeah, so this is one of those things around that kind of fluidity and flexibility in research, is that they collected this data, they were generating this data, they had the specific question they wanted to answer, realizing that it wasn't quite playing out the way they wanted, the comparative data sets that they were hoping for. So when we use, for example, pollen sequences, we need to have these very well-known sequences in a region. If we don't have them, so in this case, if you don't have these well-known microorganism sequences, now they have it for this site, but now they can't use it for other sites. So then they started to think, as your classmate was saying, as Maddie was saying, okay, what else can we use this data for? Oh, well, let's look at what other analogs that we use comparatively for paleoenvironmental reconstruction, what else we use them for? Well, if we're using things like pollen for dating, maybe we can use microorganisms for dating as well. So that's one of the key things I liked about this, and why I assigned it was because I wanted to show you that even failed, or even data that's generated that doesn't allow us to answer the original research question we had, is not a failed project, right? That thinking about how it can be applied and what the data could potentially tell us is very valuable, especially in archaeometric research. Okay. So again, what methods and techniques are they using to do this? Well, it gets pretty sciencey, doesn't it? They start talking about the media that they're using, right? So growing these microorganisms so they can identify what was present in the sediments, right? So they spend a lot of time being clear or explicit about their methodology. Why is this important? Why is it important that they're sharing what they did with those of us reading this article? Yeah. Yeah, so we can replicate it, right? We want to be able to try it, because they say specifically in this that this is a test case. They were curious to see if it can work. They think it might work, but now what they're saying is, hey, we need other folks to do this, because let's not be too caught up here in the reality of this. They actually want people to do this so they can compare it, so they can do their paleoenvironmental reconstruction work. They want other people to do this, but they're also saying, hey, if you do this too, we might be able to get some better dates and have a more refined sequence in the area. So we're going to start us off. Now we know what the relative sequences of microorganisms in this particular site. Tell us what you get. Well, how do we know that we can compare what you get with what we got? Well, we're going to use the same methods. And if we use the same methods, then we can be assured that we're replicating our results, right? And we're replicating, not duplicating. Although other people could then go sample the same site, right? And hopefully generate the same information, right? That's another way of testing this. So yeah, being transparent in methodology is extremely important. Okay. What are some of the assumptions they made? This one's a bit harder maybe to get for this potentially, seeing that it's our first article and we're engaging with this. Let's think about, what did we just talk about this class? What's one of the most important relative dating techniques? So what's one of the assumptions they're making? We want to use pollen or microorganisms like this to date a site. Yeah. Exactly. That what is present isn't impacted by time. Right? What else? Great. So where are these microorganisms being extracted from or sampled from? Why can they use it as a dating technique potentially? What is it linked to in the archaeological site? Where are they getting these microorganisms from? Where are they from? There's a term here that says right in the title there, viable paleosol. Does anyone know what a paleosol is? I know some of you do, potentially. Those of you taking geology courses probably come across this term. Old dirt, paleo, old, soil, old dirt, old soil. So these microorganism assemblages are coming from sediments or dirt. And so when we think about sediments or dirt in the site, what should we be thinking about in terms of dating? Stratigraphy. So what are the assumptions that they're making? That the stratigraphic sequence that they're basing this chronological sequence on, this relative sequence on, follows the principles of stratigraphy as outlined, right? That the oldest units, therefore the oldest assemblages of microorganisms, were at the bottom and the younger ones were on the top, right? And hopefully, if there's any conditions under which those assumptions have not been met, they have been also articulated in this article. Well, there's a possible intrusion here, or these are some possible effects. They're also assuming what about microorganisms in sediment themselves? Think about security of context. What are they assuming about this? Yes? Yeah? So that the density is important, that it tells us something about what was actually present at the site at this time and reflects what microorganism kind of quote unquote life was like in the past. That the microorganisms are not mobile within the sediment, right? That they're not moving around between the various strata or between the various contexts, right? Which would mean that using them to date the sediments and date the artifacts by association is not problematic. So there's a lot of assumptions in here. But most assumptions, this is where I find that this isn't always clearly captured in archaeological writing. They're really good at talking about method. We are really good at, I was bad about this too. It's only in recent years I start to really realize this, but assumptions and articulating those, right? They're more implicit, they're more implied than they are explicitly outlined. We're really good at talking explicitly about methods. We're really bad about talking explicitly about the assumptions we bring or bias we bring to our research. And they're making a lot of assumptions about the stratigraphic sequence they have. Now, based on what I know about this site, I don't have any problems with them because there's a lot of great control over the excavation and work that's been done here, and it's confirmed by some of the other dates. But we still have to remember then that if we were to apply this method at another site, we would have to be thinking about these kinds of assumptions that are underpinning this research. Okay. Good work, folks. That's our time for today. So we'll post an update. I'll revise the due date for the first assignment and the second one as well. I was just looking at the dates on the break. The third one won't have to shift. It'll be fine. We'll be okay for now. At least, who knows, maybe we'll want to shift it when we get to that point. Remember that I'll only shift things that were advantageous to you, so I'll never move up the due date. I'll always give you more time, so I'm just going to do that without getting, your formal permission to do so. If anyone has a problem with me giving you more time to write the assignment, you can include that in your course evaluations. Okay, and I'll take that under consideration in the future, but I'm anticipating no problems. Other than that, be well, Take care, stay safe, ask me questions. I'll update the notes. I'll get everything posted to you. I'll see you 1 week's time in person. Same bat time, same bat channel.